please. Let's start. Good morning, everyone. Always very busy time. Okay, so good morning, everyone, and welcome for this ninth CAMS General Assembly here in Prague. We are very, very happy to welcome you here, and this is very nice to see you all, this CAMS community for this new event. So we are here in Prague, hosted by the Charles University. Many thanks to Charles University. This is a great city, a great place. And yesterday we had this reception in the Carolinum building. It was very wonderful. So many thanks, really. So we will start now our plenary session. So you have seen, looking at the agenda, that it will be a quite busy meeting. So we will talk about, after the more executive introductions, we will talk about user engagement within CAMS. We will talk about use of Earth observation within CAMS. We will talk about the research projects that support CAMS evolution, and tomorrow will be more dedicated to, I would say, the review and discussions, conversations about progress of work within the various components of CAMS. So I hope that you will enjoy the meeting. I will stop here, but I think that there are some housekeeping rules that should be shared. So first, you have, yes, we have an innovative approach for the questions. You can ask all your questions whenever you want, of course, after the presentations. But if you don't want to take the microphone, you can send your question using this Slido. You have the QR code, so there is this Slido approach. So please do what you like to ask a question. People online, because we have people online, and I would like also to welcome them. Do not hesitate to also ask questions via the application, or it should work. Regarding housekeeping rules, what do we have? So we will have coffee, lunch breaks that will be taken at the second floor, I think. And we will have a dinner tonight. So for the Q&A, I've already said. You can also join our conversations on Blue Sky. Do not hesitate also to tell us what are your impressions about the meeting. So you're completing the post-event survey. This is very important to have your feedback. Just to let you know also that all the presentations will be recorded and available on the website. And you have certainly noted that we also have this innovative approach thanks to Christina's team and the NCP, the national experts who contributed to this nice area with posters. You can have a look during the coffee break to the 20 posters that have been prepared by the national experts involved in the national collaboration program. So they will stay until the end of the event. And I think that I've made a mistake. This is not the second floor for the coffee break, but the third floor, isn't it? Okay. So with that, let's start. And I'm very, very happy to welcome. Many thanks to you, Mr. Michal Zak, who is the Vice Dean of the Faculty for Public Relations.
Yeah,
thank you.
Thank you. Good morning, everyone. Good morning, everyone. It's my pleasure to be here and to welcome you on behalf of the Charles University, Faculty of Mathematics and Physics, and my home department, that is the Department of Atmospheric Sciences. And I was asked, and I would like to tell you something about our university, our faculty, and our department, and our cooperation with Copernicus and CAMS especially. So, as probably many of you know, the Charles University is the oldest university in Central Europe. Of course, it depends how Central Europe is defined, but it was founded in 1348 So it's more than 665-year-old. And it was founded by the Charles IV. And by the time there were 4 founding faculties, as you can see, theology, liberal arts, law, and medicine. And now it is the largest and the best performing research institution in the Czech Republic. It offers over 600 study programs, and it has 70 faculties. So it's not very easy to know each of them and to, how to say, yes, to be the rector of the Charles University. It has buildings not only in Prague, not only here in Prague, but also in Pilsen and in Hradec Králové. And regarding the people, because it's the most important part of the university, of course, so we have over 9,000 employees, including over 4,000 academic and research staff, 50,000 or more than 50,000 students, and almost 8,000 graduates per year. And of course, we have not only students from the Czech Republic, but from many countries abroad, as you can see. And it's a very nice thing or good thing to have this international students here. Of course, Charles University offers, let's say, a number of standard programs that probably you would expect in such university. And but there are also some programs that can be only studied in the Charles University, like, for example, meteorology, of course, and, for example, Egyptology, physics of nanostructures, and so on. So this is a very broad spectrum of programs that can be studied in our university. And of course, there is very large international cooperation. I don't want to go through details, but you can see that there are many programs and international exchange. That's, of course, very important, and cooperation with our European university alliances and so on. Erasmus Plus is one important part of our university. We have 3,400 cooperation agreements and about 4,000 places for students that can be here and that can come and share their experiences and vice versa. And also we are part of 4EU Plus, Alliance of European Universities. As you can see, there is some schedule of this project. And last but not least, the third role of the university is the popularization of science. That's, I think, very important. We have a few, let's say, main topics in this field, like, for example, Didacticon. That's really interesting part of our university. It's a campus in the city center, and it is for popularization of science, not only for the students, but also for the adults and young people. And it's really, it became quite popular in the last years. And yes, FameLab and Researchers Night gonna be in 3 weeks. And many of you probably visited yesterday Carolinum, so you know this building or the headquarters of our university. Now let's move to our faculty of Mathematics and Physics, that we usually call it as a MathPhys. And it was founded in 1952, so in 2 years we want to celebrate 75 years of our faculty. And we have more buildings, not only in the headquarters. That's actually, I don't know how this is, yes. It's not here. This is the headquarters of our faculty, behind the bridge on the left side, if you look out the window. But we also have 4 more sites. The faculty provides education for more than 2,200 students, and we have, let's say, three main fields of study, like computer sciences, mathematics, and of course physics. But also we have a very important part, it is teaching of these disciplines at elementary and high school levels. And since 2013-2014 academic year, we started to provide fully English taught bachelor's and master's program in computer sciences and master's program in mathematics and physics. So it is possible to study many of our programs in English, fully English. Also, Matfis is one of the most important scientific institutions in our country, and most of our graduates pursue practical careers in local or multinational companies. So, from this reason, we want to say our priority is to ensure that theoretical tutoring should meet its practical application. Because sometimes Matfis is thought to be more theoretical than practical, but the reality is not the case. And let's move to our Department of Atmospheric Physics. That's in the part of Troja, the city quarter Troja in Prague. And our department, as you probably would expect, offers comprehensive study of atmospheric sciences, and we provide training for professionals in the fields of various fields of meteorology and climatology, from bachelor to doctoral level. And of course, we made research and study in many issues with high scientific and social impact. And research projects are a very important part of our work, either with domestic or foreign partners. And regarding the scientific and educational activities, we focus on in several key areas. I don't want to go to the details, but just to make an idea what we are talking about. And yes, so you can see that, let's say, all topics in meteorology and climatology are covered in our department and our study programs. And now let's move to CAMS. Our department or faculty is partnering CAMS since 2017, and it is in the Global and Regional Emission Project. And we made a big effort, or the big part of our cooperation is in development of long-term inventory of biogenic volatile organic compound emissions from terrestrial vegetation, that is called CAMS Globe Bio. And what's good that this dataset is used not only by the research community in the CAMS, but also outside the community, so it's quite, or became quite popular, maybe important. Also, we use the data of European anthropogenic emissions in other two projects that are now being done in our faculty department. It's Aramis and Horizon Europe. FOCAI Horizon Europe. The Aramis is the project of Technology Agency of Czech Republic, and we focus there on tools for air quality assessment, modeling of secondary organic aerosol formations, and make some sensitive analysis of these formations. And the FOCAI of Horizon Europe program is, our project is assessing the role of non-CO2 drivers or forces over Europe. And it also use CAMS emission data in connection with the present day model analysis. Then, just to know, to let you know, we also have our colleagues in the Department of Geophysics that use Copernicus services, but it is all Copernicus data from Copernicus Marine Service. And they made project that should answer the question if we can isolate the ocean-induced magnetic field from swarm magnetic measurements and use it to monitor the dynamic state of the ocean. So it's our colleague in Department of Geophysics. And then other part of our university is Faculty of Science, and they use climate change service data in the Department of Applied Geoinformatics and Cartography. And they are also member of the Strategic Advisory Board of Destination Earth, and in also already mentioned Campus Hybernska, they established Copernicus Academy CZ office 2 years ago, and this office serves as a contact point for existing and potential end users of Copernicus data and services in Czech Republic. So it's quite interesting and important for collaboration between various institutions like educational, public, or private, and also the commercial sector can be involved in this collaboration and cooperation. So that was from my side to give you some brief introduction. Once more, welcome to Prague, welcome to the General Assembly, and I wish you a nice stay, fruitful days, and have many success. Thank you.
Many thanks, Zach. Maybe if there are some questions or needs for clarification for Zach? For Michel, Professor Zach, sorry. No? No? I think that Elizabeth wanted to... Okay. Okay.
No, here. And then
Because we But many thanks, Mr. Zach. Thank you very much. And our next presentation will be given. I'm delighted to welcome François Wackenhut from DG Environment from the European Commission. François is the head of the Clean Air and Urban Policy unit, and I think that François, you're online, and you will update us with some news about air quality policies that are currently ongoing. Hi, François, I can see you.
Yes, good morning, Laurence. Good morning, everyone. It's a pleasure to be with you. I wish I could be in Prague. What a wonderful place to be. And hearing what Laurence said about the program on the social side, I'm missing a lot. And obviously, it's a very impressive venue to be meeting at Charles University, as we just heard. So I'm going to indeed take you through the latest developments on clean air, but as this is a community I've been privileged to address on several occasions, I will try to be short on the elements that some of you may have already heard and focus primarily on the CAMS relevance, because this is really the core topic of interest today. So most of you are familiar with clean air policy at EU level. And so I will only say that, we work on a three-pronged approach, and I will address two of those elements today. The first one relates to ambient air quality with the maximum concentration of air polluting substances, because we revised our standards over the past years, and that opens new opportunities for cooperation with CAMS, about which we're particularly delighted. And the second element that I will emphasize is the National Emission Reduction Commitments Directive, for which we establish national emission totals for 5 pollutants, and we're in the process of evaluating legislation. There are opportunities already today in terms of cooperation with CAMS that have been critical to the advancement of our objectives. The cluster I will not touch upon today is source-specific emission standards. This is an essential component, but this is in the interest of the focus of the discussion today, not what I will emphasize due to time. Does EU clean air policy work? I think we can safely say that the answer to that question is yes. And the graph that is before you shows this. As you can see that between 2005 and 2021, the situation has been decreasing significantly, steadily. This is still a source of concern, as every health impact pollution is obviously something that cannot allow us to rest, but the trend is very clear. We've reduced attributable premature death by 45% over the period. So this is something that puts us on track to deliver on an objective that we established under a overarching strategy on zero pollution, to achieve by 2030 a zero pollution action target on clean air, to reduce the number of premature deaths attributed to fine particulates matter by 55%. And you can see on the graph that we are on the right track for that PM 2.5 trend to be achieved. But let's focus for a second on where air pollution remains a problem in Europe. And I'll illustrate that first with PM 2.5, and then I'll go to NO2. Most of you, again, know this very well, but when it comes to PM 2.5, the situation remains most critical in Eastern Europe as well as in Northern Italy. But this is not to say that all the rest of Europe is immune from the problem. And when it comes to the overall WHO guidance level, we can see that we're 95% above when looking at all our monitoring stations. So obviously, there's still work to be done. On the right-hand side, you can see trends in various countries that report to the EEA. And clearly, again, you see wide discrepancies from Iceland at the very left end to Bosnia and Herzegovina at the very far end. When it comes to NO2, the issue is different in the sense that all urban areas are affected. We've seen steady improvements over the past period as a result of changes in regulation in relation to road transport in particular. And we will see some further improvements. But again, if we look at the overall picture vis-a-vis the WHO guidance level, 74% of the monitoring stations remain above. And again, the trends across countries show wide discrepancies, albeit perhaps less marked than for PM 2.5. So with that in mind, we revised the Ambient Air Quality Directive. I will not take you through the full journey. It's been a long one, and actually many CAMS partners have been part and parcel of the exercise, and we're very thankful for that. We started this exercise back in 2020, and we finished it in 2024. So you see that this was a long journey, one that took us through commission work, but then, of course, stakeholder consultations and a lot of interinstitutional work with the member states in the Council of Ministers of the EU and with the European Parliament as co-legislators. We now have new legislation that was adopted on the 23rd of October last year, and that legislation is called a recast in the Brussels jargon. That is because we had two pieces of legislation before, from 2008 and 2004, and they've been merged into one piece of legislation on ambient air quality and cleaner air for Europe, and that is the framework that we have to work under. This is not the end of the journey, because member states now need to transpose this legislation by December 2026, because what we have is a framework at EU level that needs to be translated into the realities of member states and their legal orders. And that is what the transposition process is about. So member states are very busy with the transposition process as we speak. I'll just highlight key elements from the text from this slide, and then I'll skip through very quickly the ensuing slide so that we can get straight away to CAM's role. But the four key novelties of the directive relate to those clusters that you see in the boxes here. The first one is environment and health. This is arguably the most visible cluster to the public, because this is the one through which we've established what we call intermediate 2030 EU air quality standards. So we've revised towards more ambition the air quality standards at EU level. This has received a lot of attention, deservedly so, because this is something that is very meaningful, and we've aligned more closely with the WHO guidelines as they were revised in 2021. But that includes other elements as well, from the establishment of a broader zero pollution objective for clean air by 2050 to the inclusion of postponement mechanisms for deadlines in order to cater for specific conditions that relate to climate, orographic, domestic heating, and projections that are made by the member states. We've also, interestingly, introduced new metrics and average exposure obligations, which is also essential because we cannot work only from the so-called limit values that we have per pollutant. We also need to look at the average level of exposure if we are to address effectively health impacts. So that is cluster one. The second cluster that I would emphasize that is very relevant to CAMS is monitoring and assessment. We've refined approaches to air quality monitoring, and we've increased the use of air quality modeling. And this is something that is particularly useful because obviously last time we revised our legislation was in 2008, and the world and quality of modeling has improved significantly in the meantime. So we need to tap into this. We've also provided additional information on representativeness of sampling points to better inform air quality action. And lastly, we've introduced monitoring for pollutants of emerging concern, be it ultrafine particles, black carbon, or ammonia. We will now have a source of evidence that will be available that will then inform the policy decisions on whether we need to consider, when the first revisions come, some possible regulation of those pollutants beyond their monitoring. So this is an essential element that was added. Third elements in clusters, governance and enforcement. We've introduced a regular review mechanism so that we have a dynamic implementation process, because the science, as we've heard from the professor just before, the science of clean air evolves constantly. Atmospheric modeling, but also all elements relating to the knowledge that we have on the health impacts, on the environmental impacts of air pollution evolves constantly. So we need this to be taken into account in the same way as technological developments, innovation developments that can have an impact on abatement measures also needs to be taken into account. So this is what we've introduced, and the first such review will take place in 2030. We've introduced elements to make air quality plans as a key management tool to address air quality in Europe to be more effective. We've improved enforceability with new provisions that look at access to justice, at compensation, and at penalties. So this is to reinforce the citizens' dimension. And more transboundary cooperation on air quality. I'll come back to that because this is an issue that is certainly dear to a number of member states, certainly in the Czech Republic as well. And we will explain a little bit more why that is relevant to CAMS as well. Lastly, information and communication. More up-to-date information on air quality. Requirements for air quality indices to provide hourly reporting of available air quality data. And lastly, informing the public about possible health impacts and providing recommendations so that they can be actionable. So this is a tour de force on what's in the new directive. I will not dwell on the details of it, other than show you that, this was the result of a very thorough impact assessment work that looked at a number of criteria: achievability, mitigation cost, gross benefits, benefit versus cost, and health impacts, when it came to the definition of the level of ambition on the new standards, and that is looking at PM 2.5 in particular for the analysis that was carried out. And that led us to new standards, and you can see on this slide the new standards. I won't dwell on them in detail. Many of you are familiar with them. I'll just highlight PM 2.5, where we're moving from 25 micrograms per cubic meter to 10, which is a significant leap in terms of ambition that brings us much closer to the WHO guideline level. And as I said, our commitment was closer alignment, and you can see that this is something that is delivered upon. If you go down to the other pollutants, you will see similar illustrations of it. We have also done that for the short-term dimension, and that is what you can see on this slide. Again, I will, of course, leave the slides for reference so that there can be use of them for background from your side, but I won't dwell on the details of them now. On the air quality maps, plans and roadmaps, you can see here how the approach is going to be devised. But what I wanted to emphasize further is more where CAMS comes in. And CAMS comes in explicitly in our legislation. We've got a recital that recognizes the Earth observation and CAMS dimension explicitly, and that is what is before you on this slide. This is a first. I think it's a pioneering approach in EU legislation that hopefully will be replicated in other pieces of legislation, but we're particularly pleased that this is so, and that CAMS is recognized as a key partner of ours in the delivery of our objectives. And that is why we also would like to share with you CAMS relevance to the directive in a nutshell on this slide. So use of CAMS information to quantify contributions of natural sources to air pollution. Several of our member states actually already use CAMS products to identify contributions of natural sources to air pollutant concentrations as regards exceedances in the context of our legislation. So this is, as you see, a very concrete use of CAMS, which we will see expanding going further. Secondly, use of CAMS information to quantify contributions to background air pollution. This will require collaborative efforts with Fairmode, which is the main framework that we use in terms of partnering experts to advance this work, and with the relevant research networks, including EMEP in the context of the Air Convention and Actris, to strengthen the validation procedures. Again, very concrete uses that we want to seek expansion on. Use of CAMS information to identify transboundary contributions to air pollution. I've mentioned just earlier how sensitive an issue it is. This is something we need to expand, and that CAMS can bring us relevant elements to do so, about which we're very thankful. Use of CAMS forecasting information, including as input to the EU Air Quality Index that the EEA maintains for us. Use of CAMS downscaling activities, for instance, when it comes to health risk assessments and in the Copernicus Health Hub, or as input to the EEA Joint Research Center Environmental Health Services. And lastly, use of CAMS information to support air quality plans, one of the key vehicles to advance air quality management in Europe, including source allocation services and scenario development. So this is to give you a very clear illustration of how relevant CAMS is to the directive, how much we will depend on it, and how much we look forward to expanding the cooperation that will go with it. So what I would like to do now is more move to the neck very briefly, because my time is short, and I would like to do the same on the neck. So as I said earlier, we are in the process of evaluating the NEC directive. The NEC directive follows the indicative timeline for the evaluation. As you can see, it's also been a long journey. We started it in early 2023, and we will finish the evaluation at the end of 2005. The planned adoption of a staff working paper that will conclude this work is December 2025, and we will present that at the Clean Air Forum that I'll come back to in a second, where CAMS again is a key player, and we're delighted about that. But in order to do the evaluation, we've been building upon knowledge evidence gathering, and one key element is the fourth Clean Air Outlook that was adopted earlier this year in its fourth version, as I said. So that was in March. And this is a document that is crucial, that we've adopted in 4 different versions already. It's a biannual publication, and it helps us to track progress. And as you can see, for the 5 pollutants that we look at in the NEC, we can see steady progress for 4 of them, less so for ammonia, obviously, and for reasons that many of you will be familiar with. But you have here also projected emissions of PM2.5 in EU 27. 2030 is the box that is gray, and 2050 is the red box. And that also shows the overall projected pictures that we need to build our policies upon. This has implications for air quality. This map here shows notable improvements, yet in 2030 and even in 2050, we can see that large areas will remain exposed to levels above the WHO guidelines of 5 micrograms per cubic meter, that is for PM2.5. And so that calls for action. What this translates into in terms of policy objectives is that we are on track, and I said that earlier in my presentation, to meet our zero pollution target of reducing health impacts of air pollution by 55%. But we need to do more. And CAMS comes into the picture again for the future implementation of the NEC. And that's what I would like to dwell on, to take you through those elements. Firstly, we are using Copernicus, and in that case, it's not CAMS, but C3S. We're using temperature data to account for exceptional meteorological conditions within one specific year in those flexibility mechanisms under the NEC reporting that we have in place. So interestingly, Copernicus for us expands even beyond CAMS, and we know excellent cooperation between CAMS and C3S, and those elements are elements that we'd like to build further upon going forward. Possible use of CAMS, emissions and concentrations, for national inventory and other reporting under the NEC is something that we want to build upon in the future as well. Possibilities to do gap filling, support on reported LCP, so large combustion plant industrial data, update of the diffuse emissions and forecast of emissions. So that is the link to industrial emissions legislation in Europe, something that is critical for us to also achieve in future. And lastly, possible use of inverse modeling to flag possible inconsistencies and gaps in the reported data so that we have a more accurate picture. So I know that this may seem to be specific and sometimes at the micro level, but this is to illustrate how essential CAMS and C3S in that case as well is to the implementation of our emissions legislation under the NEC. So in conclusion, because time is short, obviously, my key and core message is that there's potential for enhanced cooperation with CAMS and C3S on clean air policy, and that we will be working intensively with the CAMS community, and we have engaged intensively, and we're so grateful with the level of reverse engagement from CAMS in our processes in order to achieve those objectives. And we will have a key opportunity to do so at the 5th EU Clean Air Forum that will take place in Bonn, in ECMWF, hosting it. And, I could not be more thankful for ECMWF for that joint venture to have been initiated. It is going to be a very promising event on all the accounts that I've provided you glimpses on. We will go into more details on all of that at the Clean Air Forum, not least in the context of the release of the evaluation of the NEC directive, but much beyond, because the space community will be much, and the Earth observation community will be so closely invested in our discussions that I think we'll have breakthrough discussions that we'll be able to advance in Bonn. So we look forward to seeing as many of you as possible in Bonn. We're extremely grateful to Laurence, to the whole CAMS community for the engagement, and I think the future is going to be even brighter. Thank you very much for your attention, and again, sorry not to be with you in person in Prague.
Thank you. Thank you so much, François, for this presentation. It was a very complete overview in short time of the air quality legislation, and also the areas of collaboration that we already have and that we will develop also in the future. Just asking to the audience, are there some questions for François? Or online? No need? It was very clear. Oh, there is one. Oh, sorry, Carol. Yes, please. If you could introduce you. Yeah.
Yeah, I'm Carole Daniel from the French Space Agency, and I thank you for this very interesting presentation. I was wondering, you mentioned the effort of modelization and in situ network and EMAP data, but you did not mention the observation from space, which is very now, which have done a lot of effort to cover this issue of air quality and bring some new information and observation from space. So I would like to know how you incorporate and support this action from the DG environment aspect. Thank you.
Yeah, thank you very much, Carole. A very good question, and actually something that I should have emphasized. You're absolutely right. There's a wealth of information that we can and must build upon in implementing future legislation and actually guiding its further development. So this is resounding yes to your question. We are to some extent already, and this is something that we want to expand. And the whole focus of the Clean Air Forum in December is precisely to bring those communities closer together to the extent that we can still improve the cooperation and further it. And this is something that we will be focused on very strongly in the first phase of implementation of the new directive when it comes to air quality, and in future work on clean air more broadly. So absolutely spot on.
Thank you. Thank you very much. Other questions? No, I missed nobody. Okay, many thanks again, François. I know that you will have a very, very busy day, so many thanks for joining us for this presentation and for your kind messages. And see you soon. Bye-bye. Thank you.
Thank you.
And the next speaker will be Hugo Zunker. You know Hugo, maybe, from DG Defis, who manages Copernicus services, activities, and in particular CAMS. So this is always a pleasure to welcome you. The floor is yours, Hugo.
Thank you very much, Laurence. So good morning everybody. So after François, I take a bit, zoom out a bit, and maybe I address a bit the General Assembly here in a more general way. So first of all, it's a pleasure to be here. So thank you very much for inviting me. In particular, being here in Prague. So in the Charles University, as had been pointed out previously. Czech Republic has quite a strong history, including with Earth observation and Copernicus. It's home as well of the agency of the EU space program, as many of you will know, of course. So that is really a good place and a strong place here to be there. And the General Assembly is, for me as well, always a good opportunity to see a bit the progress, to understand a bit in a bit more detail what is being done. Copernicus is the European Union program for Earth observation. And we have teamed up here with the European Space Agency, as you know, and basically built over decades by now really the most sophisticated system for Earth observation and monitoring. What is really unique, and I don't fail to say that with all the services, what is really unique worldwide is this close integration between the observation data and the services, which turn this data into domain-specific information products according to user needs. So the continuity of and the sustainability of the services is really not in any other country or region of the world present. So this is very unique, and I think you can be proud of what you have achieved over the last 10 and even more, 15 years, because that's really incredibly strong added value to the program. Now, still we are in the space program, so I will talk a bit about, or remind ourselves about the launches of new satellites that we have had this year. So there was a bit, I would say, delay in launch services, as most of you are aware. So, and now 2025 is really the year of the atmosphere, if I may say so. So it's really started with the Sentinel-4 on the Meteosat third generation S1, which really will provide hourly information over the European region, and it's complemented by METOP A1, the second generation, which will basically give global coverage on air quality information each day. So Meteosat was launched 2nd of July. The METOP was launched 13th of August. And so, I mean, some in the audience may know even better. I think the satellites are doing all well. The instruments are supposed to being switched on quite soonish, I think. Maybe even they have. So that's it's very exciting to see how these instruments are going to perform actually in space, and which value this data will have for, in particular, for the service that you are providing here. On the atmosphere monitoring service, so clearly the air quality is at the heart of the atmosphere service. So both, I think, forecasts, but as well monitoring, analysis of the past, reporting, and so on. So I will not even try to replicate what François just said in a much more competent way than me. But I will still join him in emphasizing that the recognition of CAMS in the air quality directive is really a very significant step for the program as such, and it is something we want to replicate in other areas, and in order to really bring Copernicus Earth observation and the services much more, or even more, to the policy making process. So that's really difficult to underestimate the significance of this Copernicus being mentioned in this legal text. I would like to address as well the greenhouse gas monitoring and verification service, which is in the process of being developed by you. So this remains quite high on the political agenda, and the monitoring of the emission of greenhouse gases is obviously key to manage the climate change. So we have suffered delays from our satellites there from CO2M development. So now these satellites are expected to be launched in the first one in summer 2027, second one begin 2028, and the third unit roughly 2 years after that. So this is unfortunately quite a delay versus the initial schedule, which would have seen the satellites basically launched end of this or begin of next year. And now I want to come back to yet another launch, and this makes obviously the microcarp mission from the French mission microcarp much more interesting, or even more interesting for us to exploit this data as well. So microcarp has been launched on 26th of July as well, very successfully. I think there as well the colleagues are working on deploying satellites and initializing instrument and so on. Maybe we will hear on that more during the day. And we are in talks with CNES in particular to see how we can, on one hand, support the mission in its routine operation with EUMETSAT, and as well kind of maybe welcome microcarp as well in the family of contributing missions in one way or the other. So a third area I would like to address is the methane emissions. So there has been the development of the Methane Explorer. So it basically allows you to explore emission data according to type of source, the size of the emissions, but as well the nature of the emissions. So is it one-off, is it continuous, is it intermittent, and so on and so forth. So this type of data is shared with and used by the International Monitoring System Methane Emission Observatory, IMEO. And so in general, this Explorer is quite a significant success for CAMS as well. It's really turned out to be very attractive content on the CAMS website. To make a bit the bracket here, all of these stories, these three elements I mentioned, are quite closely linked to important policy files of the European Union, and which emphasizes as well the need to have really policy-ready products in order to have a good uptake by policymakers. So this is really essential. There needs to be a good interaction between the production and the consumption in order to achieve that. No? I can make a parenthesis here, maybe for the thematic hubs. Some of you may be aware of them. So these are basically tools that have been introduced a bit late in this program phase, so they suffer a bit from lack of funding, so that they are basically implemented on the best effort basis today. But the important thing here is that they help to present the products from Copernicus services, from Copernicus satellite, in a way that is understandable by specific user communities, in particular by communities which go across different services and different disciplines of Earth observation and Copernicus. So these are here to stay, and we will have, or we will try to extract from the, I would say, first implementations of the hubs as much as possible in order to allow us to have a good concept and a sound and robust concept of these things for the next MFF. So for the next MFF tomorrow, there will be, I think, a specific opportunity to discuss a bit about that. So I only highlight a few issues here. So a new element is what is called the Earth Observation Governmental Service, which is going to be set up for basically governmental and dual-use applications and user communities, and this will be done outside of, or is proposed to be done outside of Copernicus. So it will be sitting next to Copernicus. The next MFF, it had been published on 16th of July. So there's a dedicated website where basically all sorts of documents, draft regulations, and so on all can be found. It's characterized by further consolidation of programs. So, for instance, what is today the space program, the IRIS-2 program for satellite communication, the EOGS I mentioned before, defense, resilience, security, all that is going to be one area in this new competitiveness fund, which is going to be there in the next MFF. And so, while we have a lot of information on all this, still the global budget figures need still to be broken down. So until we can understand what is the figures we have exactly for the Copernicus, for the services, for the atmosphere services, and so on. So this is still work that needs to be done. I would like to say member states and the European Parliament are, of course, extremely important for all these budget discussions. And so we can see, we have observed that policymakers rely on space assets, such as Copernicus, more and more. And they expect more and more from us. And which means basically that the budget experts that are negotiating this budget with member states, between member states, they need to be made aware that operational capacities need really adequate funding, otherwise they are not there when you need them. So in this community, all of us, we have a role to play here in order to educate and to advertise basically these aspects and the benefits of Copernicus for policy making and for member states and Europe as a whole. So with this, I would like to stop here, and thank you very much for your attention.
Thank you. Thank you so much, Hugo, for this nice presentation, which gives us a good overview of CAMS in this EU space program landscape. So that's very important to have also this overview. Some questions for Hugo, please. Yes, Leonor.
Yeah, Leonor Terrason from NILU. Thank you very much, Hugo, for this overview. I just would like to have a reflection from you on what do you expect this EU governance system, the GOGS, to affect the Copernicus services? How do you see that?
Yeah, well, obviously all of that is still a bit in the making. There are specific working groups with the respective member states, authorities to discuss this. I think the main impact I would see mainly in the area of the security service, obviously, and the emergency management service. For the other Copernicus services, I think there could be an interface in one way or the other that we might want to establish, but that's, I would say, it's my thinking. That's not yet there. No? A key point of this, or key concept of this EUGS, would be clearly to, on one hand, to pool member states' capacities in that area in some way to make those assets a shared asset, and to have everybody getting more in return. And then, to some extent as well, to have maybe EU space infrastructure to complement these assets where there are gaps. No? But these would be very different types of satellites than that we have for environmental purposes.
Thank you. The questions? No? Not online? Okay. Thank you very much, Hugo. And next presentation will be online. I'm very happy. Welcome Dusan Schrenek, who is Special Advisor at DG Climate. And Dusan, you will tell us more about the last update from DG Climate, but also how we could enhance maybe collaboration with DG Climate as well. So Dusan, many thanks for being here with us, and the floor is yours.
Thanks, Laurence. Ladies and gentlemen, firstly, let me apologize for not being with you in person in Prague, but I'm really grateful for an opportunity to address CAMS assembly online. And I would like to highlight that Director General for Climate Action, DG Klima, is extremely happy and pleased with the quality of Copernicus services, especially of the Copernicus Atmosphere Monitoring Service, CAMS. And I'm convinced that the creation of the CAMS and Copernicus Climate Change Service has proven to be a visionary step, laying a robust foundation to address the challenges of the climate change and atmospheric pollution. I think that Europe can be proud that over the past decade, Copernicus became the world's most advanced environmental monitoring system. Its 6 services, atmosphere, climate change, land, or marine, emergency, and security, deliver data which supports everything from air quality management to disaster response and climate adaptation. This data is essential for climate policy. CAMS and emerging CO2 MVS provide the scientific foundation for tracking emissions, supporting national inventories, and assessing progress toward climate neutrality. Copernicus is not just a technical tool, but a strategic enabler of Europe's climate goals. CAMS is already fulfilling this mission by providing high-quality data on air pollution, greenhouse gases, and solar radiation, supporting informed decisions by governments, researchers, and citizens. Its operational forecasts are used by environmental agencies, health authorities, and energy providers across Europe and beyond. By providing critical data on atmospheric composition and aerosol behavior, CAMS also supports scientific understanding of solar radiation modification. This activity is increasingly recognized by the scientific community as well by key institutions as ECMWF, European Space Agency, and EU METSAT. This year, the launch of satellite of Sentinel-4 and Sentinel-5 marks a major step forward. Sentinel-4 will provide high-frequency air quality data over Europe, while Sentinel-5 will expand global monitoring of ozone, nitrogen oxide, and methane. These missions are strategic investments. They will strengthen Europe's ability to deliver accurate, timely information in support of the European Green Deal, the European Climate Law, and the Paris Agreement. Looking ahead, we are excited about CO2 MVS. By combining observations and modeling, it will deliver robust estimates of anthropogenic CO2 emissions, bringing transparency and accountability to climate reporting. The upcoming CO2M mission will complement this effort, deploying satellites to measure CO2 with high precision. Together, CO2 MVS and CO2M will form a backbone of Europe's capability to monitor greenhouse gas emissions independently. And I trust that also in this area, Europe will be a global leader. On behalf of DG Klima, I would like to thank you, the CAMS team, and the wider Copernicus community for your dedication and innovation. Let's use this assembly to strengthen partnerships and shape the future together. I'm looking forward for further cooperation with CAMS, and I wish you a fruitful, successful General Assembly of CAMS. Thanks a lot.
Thank you. Thank you so much, Dusan, for this presentation, but also for your interest in CAMS and Copernicus activity, and also your support. Thank you so much. And maybe there are some questions from the audience for Dusan. We have a lot to do. That's very exciting. Not online either? Okay. Thank you so much, Dusan. I know also that you have a lot to do in Brussels, so thank you for taking some time for us, and see you soon. Bye-bye. Thank you.
Goodbye.
Okay, so last presentation, I'm really delighted to welcome our last speaker. It's speakers from ECMWF, Florian Papenberger. Florian is currently the director of the forecast and service at ECMWF. He's also deputy director, and he will be soon the general director of ECMWF from the 1st of January next year. Florian, I think it's your first time. It's in CAMS General Assembly, so welcome, and many thanks for giving this talk to us. Thank you.
Thank you very much. Yeah, it is actually, it's not my first time. It's my first time that anybody says I have to be taking up the Director General role on the 1st of January. So what will I do until then? Not much. Anyway, really welcome to the 9th Assembly here. Also on behalf of Florence Rabier, our Director General at ECMWF. I'm actually quite fond of Prague, not just because of the cobblestones and the coffee. But there's two reasons for that. The King Charles, who actually also founded this university, built my hometown, which was was a border town, then it now is in northern Bavaria. And second, I had the pleasure of working in Prague during my career at the T.G. Masarek Water Research Institute at the time. We are here together really standing on big shoulders of 2 decades. MAC, GEMS, and now CAMS. The only thing they have in common is the M. Should actually make us think. Anyway, really building this world-leading quality, and we sort of have already heard from the previous speaker how important CAMS is. I'm going to skip all of that, which I've written down. One of the key parts of CAMS is, no surprise, the IFS Compo, which is, of course, the atmospheric composition configuration of the ECMWF forecasting system. And we sort of heard a lot about missions which are going up. We should remember that actually how far we've come, that one of the first satellite composition observations, which was brought into this IFS Compo, were the modus aerosol optical depths from NASA's Aqua and Terra. And we're still actually there today. They're still valuable observations. And I think it shows us how important observations are, and no matter what the political landscape is, that we have to defend their continuity and their value, and that is not really something to do with a political color. The one thing I love about CAMS is not just a research project, it's not just an idea on a paper, it's not just something which runs for a few years and then goes away, it's truly operational. All the things which sort of the previous speakers outlined, that they are now there and we can do them, are there because we can run this 24/7. All of you make it possible that we're providing a reliable, consistent service to the world and not just something which is intermittent and goes down. This brings me sort of already to my close. I would like to sort of thank Laurence for her outstanding leadership of CAMS. I know it's teamwork. But it's always great to have somebody like her at the helm of this. The future, sort of, we heard a lot about new satellites. You may know I'm quite fond of machine learning. Don't forget machine learning. I think the revolution is not just our doorsteps. We are actually already in the middle of it, and it will overtake us faster than we can think. And every time I make a prediction what machine learning is going to do next, I'm wrong because it's either already done it or I'm about 10 days behind in my presentation. So please come up and talk to me. Thank you very much. It's an absolute pleasure to be here. I had a wonderful run this morning in Prague and saw all the sightseeing points I have to see. It's absolutely lovely city. Look around and thank you for being here.
Thank you. Thank you so much, Florian. Any questions, comments for Florian? No, thank you. So many thanks. I think that yes, we will take a photo. So okay. So I think that now we can end the first session of our agenda. And yes, it's time. We have some time for a coffee break. The idea is to come back at 11:30. 11:30, so you will you have some time to discuss, to have a cup of coffee at the 3rd floor. So see you, please, sharp on time, 11:30 for the next session.
All right, we're going to start, otherwise we have less time for lunch. The next session is focused on our users, who are, of course, the key driver of the whole program. So it's really important to listen to them. We'll start with a brief status overview of where we are in the program, but then it's really all about users. So we'll have feedback from the sessions yesterday, but also a couple of other presentations, and then finally a panel discussion at the end, which we hopefully can make as interactive as can be, but Christina will lead that for us. So our first speaker doesn't need any introduction. I think if you don't know her, you're probably in the wrong meeting room. It's a pleasure to introduce Laurence Rouy, our director.
I can see everyone. It's much better. Thank you so much, Richard. What should I do? Okay, so I will give a brief presentation with few insights about what we've done, what we have developed over the last 12 months, I would say, since the last assembly. It will not be an exhaustive presentation. And in advance, I would like to apologize if I missed, forgotten few things. But of course, Mike, now it's better? Okay, thank you. So now, so you will have more details in the other sessions, in the other presentations. So this is just to remind you maybe what are our thematic areas. It's a bit strange to have this slide that you know very well, but just to tell you that we have added 2 items that now are more and more significant in our portfolio, in our work, what relates to the storms impact and Wi-Fi impacts, and also transport of air pollutant over very large distances. This is something that now we monitor, I would say, routinely. I will show a few examples, and I'm sure that you are aware of what is done in that field. And for the other fields, air quality, development of policy tools, solar energy, ozone layer, emission and surface fluxes, climate forcing, sure that you are aware of those developments, and we'll come back to that. And you have heard the previous presentations, especially from DG Env and DG Clima. They mentioned, so François and Dusan mentioned, very concrete applications, areas where CAMS is expected to deliver something. So what relates to the air quality directives, the ambient one, but also the national emission reduction commitment directive, what relates also to the energy and climate policy. And I hope that with the products, the work that is carried out within CAMS by this community, we are already able to provide useful inputs, and we will be able to improve that. So just let's start with, maybe I should click again. It should be an animation. I don't. It's okay. So sure that you've seen this beautiful animation movie that we have prepared. It's based on IFS compost simulations. And what is very interesting, it was very interesting to see how Europe was impacted. It was in June this year by 2 kinds of long-range transport, even on one side, the impact of wildfires in North America, and on the other side, the impact of a desert storm from Africa. And we have monitored that. Also the impact on PM concentration, it has been monitored by the air quality monitoring network, and there was some impact. But it was quite interesting period that we have monitored, and we thought that it would be also a very comprehensive way to explain what we do, and to explain also how air quality in Europe is impacted by long-range transport. Coming back on Wi-Fi monitoring, just to mention that we have to remember that we have this specific activity. This is the development of the GFAS system, which is a Wi-Fi emission monitoring system. With that, we are able to monitor what happens day per day over the whole year. We also have the aerosol alert system, which allows to monitor, to look every day at what are the exceptional events that could arise, that could be the starting point for very high PM concentrations. So, of course, these kind of events, wildfire, dust, and other anthropogenic PM air pollution events are monitored and reported in this aerosol alert system. Regarding Wi-Fi, just to mention that we had a very heavy summer, especially in Europe, with wildfires almost everywhere, I would say, even in the UK, so it was more in spring, with carbon emissions calculated by GFAS for EU and the UK, which have broken records. So this is a bit frightening picture. It seems that 2025 would be already a special year. No real trends. You see what happens since 2003, because this is a question that we have been told. Are there trends? Can we say that there are more wildfires than the previous years because of climate change? We know that 2025 was a very hot year, a very special year, but you see here the picture, and we cannot say that there is a real trend. So that's something interesting to investigate. I've talked about desert dust and also those dust events that we monitor. So there are two kinds of episodes that are very relevant for the European Union, I would say. Those that impact the European domain. So very often this is the Mediterranean basin, but it can go a bit further, and those that impact the other side of the Atlantic, and especially those islands that are also part of Europe. And you can see here examples of events that occur over the last months, and you can also see the good behavior of the models forecasting those events at the global scale on the left side, and on the regional scale with the regional system on the other side. This is very good also to say, because those events are exceptional events. There are some alerts, and it's good to be sure that what we provide is quite reliable. Talking about air pollution events, we have monitored several situations this year at the global scale, but also at the European scale. So you remember that what relates to the global scale is forecasted, analyzed, thanks to the IFS Compo system model, and what relates to the regional scale is managed by the 11 European chemistry transport models that are combined to elaborate a multimodal ensemble. And just this is an example. Once again, everything is evaluated. There are two specific activities, service activities dedicated to EQC for the global scale managed by KNMI, and for the regional scale managed by Met Norway. So everything is monitored, everything is available on the atmosphere data store. Just wanted to mention that this year we have monitored once again, talking about this special summer, very significant ozone episode during summer. And I wanted to also highlight that we have also monitored pollen events, because the regional system forecast as well pollen. This is something that we don't say so often. And we had a very, very intense pollen period, especially at the beginning of the year. So this is an example. So the blue map is an example of alder forecasts in February, so quite early in the year. So now we know that we have to forecast pollen over the full year. And also, I'm happy to say that we also have signed at the beginning of the year a new contract, an in-situ contract. You know, we have those in-situ contracts that support the development of our system with the European Aero-Agent Network and with the company EZPR from Austria. So that's good news. And talking about air quality and policy tools that go with. So those have been discussed yesterday during the Atmosphere User Forum. Just to mention that those tools are online tools, so there are a number of information available on the web page, and we have published in July an assessment report of air quality in Europe for the year 2024. New shape, new design. I hope that you will have more information. Maybe you had a look at that, and it was quite appreciated by the policy users. Going back to the global system, I would like to mention also that we monitor, as usually, the ozone hole, and we have started the reason for the Antarctic one with maybe, I don't know, maybe you have more insight, but it seems that it has started a bit earlier than usually. And also what has been delivered for the previous season, and we will continue this for this season, is not only concentration of ozone, but also concentrations of ozone-depleting substances, which is of high relevance to support the implementation of international agreements, especially the Montreal Protocol. AFS Compo. So this is something that is under development. So say AIFS Compo. So Florian mentioned how fast things are running with machine learning at ECMWF. And of course, we have IFS for weather forecast, IFS Ensemble, and we want to have AFS Compo. And we have started to work on that. And with quite promising results. So what you see here are root mean square error graphs, time series for PM2.5 and AOD. And what you can see in green is so in black, this is operational result, performance, and in green, this is the last version, the most updated version of the AI version. So you see that this is very promising, and this is something that we would like to develop further, and we hope to have a prototype soon with this 10-day lead time. Oops. I'm sorry. So you will have more details about that. But just wanted to say that we have published, so now on the Atmosphere Data Store, you can access forecast of greenhouse gases, so forecast and analysis based on a setup which is detailed in this slide, but you will have more details in the further presentations, and also some activities on greenhouse emissions and fluxes that are ongoing. What relates, of course, we are prepared we develop some products that could be used to support the implementation of the Paris Agreement. This is also part of the CO2 MVS activities, and that could support also the second global stocktake. I would like to mention as well our collaboration with the Carbon Monitor Initiative, which aims at monitoring on using activity data. This is a bottom-up approach based on near real-time activity data, monitoring CO2 emissions everywhere in the world, and especially in Europe. So the CAMS contribution is more focused on Europe, but there are nice comparisons of the evolution of CO2 emissions in various parts of the world and for various years. And also, I would say, speciation according to various activity sectors. I hope that you did not miss also this new product that has been launched in February this year, but I think enhanced, improved quite recently before summer. So this is the Methane Hotspot Emission Explorer that has already been mentioned. So thanks to Tropomi data, we are able to provide an information of the hotspot everywhere in the world, methane hotspots everywhere in the world, and with a discrimination by sector. So you can see what are the emissions of coal and mine from landfills, agriculture, just to say, agriculture is not in the list of the sector because this is not monitored by the system, but there are emissions from the agricultural sector for methane. This is a question that we have been asked, so we are working on that. This is very clear also on the website, the fact that we really focus with this tool, and you can see that now we have really zooms over emitting areas. Yes, we focus on the large point sources, actually. And another activity I would like to mention, we have more details. This is also the developments that relate to solar radiation. This is an important part of our service portfolio, and very recent developments that were designed to better take stock of CAMS results, CAMS modeling results, especially regarding the aerosol optical property, to improve the clear sky solar radiation model that is developed under CAMS, and compared to the usual libraries data libraries that were used, and with quite significant improvement of the assessment, which is really to illustrate that things are always moving and improving. I will close soon my presentation, but before that, I would like to mention once again, we had yesterday the Atmosphere User Forum, and we are very proud of our user uptake and user-driven strategy. So here you have a map prepared by Christine. I think that she'll come back to that, that show you how many and where are the national collaboration programs that are currently implemented, or in preparation. I would also like to mention our activities related to training. That's very important. This is also a very important part of our strategy, and this is something that, of course, we develop with good partners and in the framework of partnership, for instance, with ESA, EUMETSAT, I've just mentioned here, for you to remember the next joint training session on atmospheric composition. It will be hosted by BIRA in Belgium. But there are other areas where we develop some training activities, especially with WMO. And last but not least, what relates to user support. So just to remind you that CAMS user support activities are now embedded on the ECMWF user forum. It gives more, I would say, consistency to our system, but also more efficiency. And also data sets that are delivered by the services, the sub-services are available on the ADS, and now under a CC-BY license. You have been informed that this has been implemented since July. And I've just put as example, because I didn't talk about that, but those are activities ongoing and performing very well what relates to global inversion of greenhouse gases, global and regional emission inventories. You will have more details in the next presentation, and I hope that we will have soon regional emissions on the ADS. And this is a community, the CAMS, there is a CAMS community. This is a truly European effort. So here are some figures. I will not go into details, but this is to give you an overview, an idea of how many partners, how many partners are involved via contract, and this is quite some budget. And to manage that, to deal with that, we need also a good, competent, and efficient administrative team, and I would like to thank them. So just you have here just an overview of how we are organized and how many teams are involved in our administration department to deal with all those contracts. Because behind the scene, behind the success, there is also a lot of work that is carried out by everyone. And with that, I would like to thank you for your attention.
Thank you very much, Laurence. Maybe time for a quick question. Guy. This should be a microphone. Just a second for the online.
Thank you for your very nice summary and presentation. You have been highlighting a number of thematic priorities, and for example, policy development or climate impacts of air pollution and so on. But the question of connection between air pollution and health, human health, was not emphasized. And I think there is a growing interest in that aspect. And I'm kind of wondering if it wouldn't be a good new direction or enhanced direction. I know it's there implicitly, but to make it more explicitly, to really start connect with the human health community on the issue new pollutants, pollen, aerosols, etc. So just a question that I'm raising.
Thank you. Thank you so much, Guy, for this question. And you will have, I will answer, but you will have also answers in Yoni's presentation, because we have this presentation on the Copernicus Health Hub. You know that in the Copernicus Hub, so there are a number of thematics that are covered by the hubs, and health is one of those thematics. And it's true that a lot must be done. Is done, not enough, certainly. It's true that you're perfectly right. In my presentation, finally, I did not highlight this so much, but just to say that we have some linkages with, of course, organizations like WHO. When we talk with DG Environment, you know that the Ambient Air Quality Directive are driven by also health impact and things like that. So we consider how we could provide useful impact to help in assessment of useful inputs for assessment of health impact. I would like also to say that we are now in touch with the institute in charge of the global burden disease, which is very interested in what we could provide to support their assessment, in fact, regarding the air pollution part. So this is something that is growing, that is certainly necessary to highlight more and to develop more, and this is on the agenda. Thank you.
All right, I think we need to move on to give the other presenters sufficient time. So I'd like to invite Cristina Ananasso, who will give an overview of yesterday's discussions during the Atmosphere User Forum within the National Collaboration Program. So the floor is yours.
Okay, thank you, Richard. And I'm very pleased to be here and to report about the workshop that we had yesterday and also some of the outcome of the National Collaboration Program. So yes, yesterday we had this recurrent meeting with the communities around the national collaboration programs, and I would say that it was a very interesting and intense afternoon. We, as usual, the agenda foreseen presentation from ECMWF expert, but also from the countries. And the idea yesterday was really to focus on activities that are ongoing at national level, relevant to air quality and emission reporting. Then we also introduced the new tool to address some other challenges at transboundary and national level. And we are going to use the grants, so at the end of this month or beginning of the next one, we are going to issue the first call for proposal for the CAMS and CP. And Ioni and Laura Carletti, that was online, presented in detail the new topic, but also this new tool that for ECMWF is really a novelty. And then the main goal of this meeting was also to facilitate sharing of experiences, lessons learned from the countries, but also from ECMWF, and also to discuss about some challenges. Something that we always do in the NCP is really to collect feedback from the countries and, when possible, to respond to their needs. For the first time, we had a poster session, and thank you, Laurence, for having approved this idea. In C3S GA, this is quite normal, but indeed for CAMS, it was an important achievement. We had 20 posters. They are still there on the panels, and it was amazing yesterday to see a lot of people, not only from the countries, but also from ECMWF and from the contractors, discussing, looking to the poster and discussing in front of them. This is a simple way to promote the discussion among the countries. This is something where I would like to put more attention in the coming months and in the coming year. As usual, I love to introduce the CAMS NCP with this timeline. Everything started in December 2021, when for the first time I presented the NCP approach and concept to the Copernicus User Forum. After less than 1 year, we had the first contract signed, and then we started this recurrent meeting. The idea is really to create a community, not only around CAMS, but also around the NCP. So addressing or putting in the center of our attention the core user at national level. The last point of this timeline is regarding, as I said, the call for proposal. That is really a big achievement for CAMS and for the people working on it. I like to divide this timeline in 2 phases, mainly. The first one that ended, let's say, end of 2023, it was a kind of a pilot phase. So we really explore a new way of collaboration with the users at national level. The contracts were lasting for 18 months. And the goal of this phase was really to reach out as much as possible all the countries that are part of the EU, but also the participating country like Iceland, Norway, UK, and recently we met also Ukraine. In this second phase, let's say that it was a kind of smooth continuation of the first one, but the contract has a longer duration, so a higher budget for the countries to spend, and with the goal of, let's say, to close somehow and to set up all the contracts with all the interested countries. In the coming months, we will close, hopefully, this phase. And really, our intention is to focus more on engagement activities, looking forward to a closer cooperation with the countries, supporting them maybe in some challenges, but also to foster the collaboration among the countries and the collaboration with ECMWF. Using also this new tool with the grants, and also promoting what are the transboundary challenges that we would like the country to address. And I have a slide on this. This is the same map that Laurence showed before. And I also had this table to highlight, to show you which are the, let's say, preferred module. Because what we offer, it was really a list of work packages, and the country could really pick up the modules or the activities that are really responding to their national needs. And here there is also a kind of response to the comment done before, because in this second phase we have a work package that is optional, but with the request to develop a demonstrator to address health or energy issues. And as you can see here, there are a lot of countries that have selected this module. And health is one of the topics that attract, let's say, more attention. So this is something that the countries can do within the NCP using CAMS product. Online, there is a new updated version of the National Collaboration Program website, and I really invite you to have a look. So let's go back to the main goal, or the approach, or the concept, let's say, of the NCP. The idea is really to support the country to use our products, CAMS product, to respond to national needs. As I said before, we offer a kind of a la carte menu of some activities that can be done with our products, leaving the country free to decide which are the actions that they prefer to develop at national level, because they are this response to needs that they have from their own user. So it's nice to see how the countries are addressing these needs. And depending on the needs, they are getting closer to the end user. Some of the countries are really working with the municipalities, for example, other with the regional agency for environmental protection. Other countries are addressing specific thematic community. The health application, for example, is a case where the focus is really at the health topic. What we ask in the NCP is really to enhance national outreach and communication. So the communication work package is the only one that is mandatory, apart from the management, obviously. We want the countries and our contractor, in this case, to communicate in national language, because we really need that our contractor get closer to their end user. And it's really amazing to have a lot of communication in so different languages. I cannot understand all of them, obviously, but it's really amazing also when I get information or flyers or publication in so many languages. And the last point where I would like really to put our attention is the Atmosphere User Forum. We created this community of experts, and I think that this community is becoming more and more mature, also with the capacity to interact directly with the CMWF. For some countries, this is something quite obvious, let's say natural, but for other countries, this is a little bit more difficult. And I think that this was a very nice way to engage with these, let's say, countries that so far were not part of the CAMS community. And we are learning a lot. I have to say that receiving continuously deliverable, contractual deliverable from countries and exchanging and forwarding them to our CAMS expert is a very interesting tool to know better about countries' needs, but also to improve our services. To complement what we have already done for the National Collaboration Program with this one tailored contract per country, so no competition, all the countries that are potentially interested can respond to our call, let's say. Now we want to complement with something that is a bit new, so we address this competitive tool at national and transnational level, because we would like to foster collaboration among countries, as I said before, on a topic of common interest. And this also brings a kind of innovation or improvement in the performance. These are the three actions that yesterday were presented by Yoni. Action 1 is on transboundary cooperation to address 3 common challenges. One is on ozone, the other one is on ship emission, and the third one is open. So it's really a bottom-up approach, and we are asking to the country to collaborate on a specific need and to find other country interest The other one is to support the national action plan. And again, we have another response to the question before. In this new framework, the idea is to promote the development of applications that connect CAMS and health in a collaborative framework. So the call will be open at the end of this month. You are going to have 2 months to prepare your proposal. Then there will be obviously evaluation, grant agreement preparation, and ideally we would like to sign these new grants before the summer. Follow-up action. Maintain and continuously engage with the NCP community. Regular interaction, share initiative, really having an inclusive dialogue, giving to all of them, to all the countries, the possibility to share their experiences. Communication and outreach, we will again focus much more on this aspect, and we will push the countries to do this at national level. We want CAMS to be translated, let's say, in so many languages. We would like also to expand the user base at both transnational or national level, giving to the country the responsibility to identify new stakeholders. Continuous listening to national needs. This is really for us a key element of this collaboration. We would like to strengthen in the future this co-design approach. We already started with the NCP, but indeed this is an aspect that can be improved together with the countries collaborating with us. And again, with this last action to promote the cross-country collaboration, to encourage knowledge sharing, joint innovation, and also some kind of harmonized services developed in different areas. I really like to close my presentation with this nice infographic prepared yesterday by Georgia during our user forum. Here you can find the key words of the discussion that we had yesterday, and you will get the presentation, so you will get also this nice infographic. So thank you, and that's it.
Thank you very much, Christina, for this nice overview. I'm going to defer the questions to either offline or maybe during the panel discussion in the interest of time, so we have enough time for the discussion. Next speaker is Joni Kusta, who will present the Copernicus Health Hub and hopefully respond more to Guy's question.
I couldn't have wished for a better introduction and entry point for my presentation. Do I need this? Yes. Okay, I need this. Sorry. So let's go ahead with the presentation of the Copernicus Health Hub. I don't know how many of you are familiar with the development of the idea of thematic hubs under Copernicus, and at the moment of their establishment or development, there were 5 key elements that the hubs were meant to address, and it was to coordinate the services, to connect with the community, to enhance and inspire collaboration, to gain user intelligence, and to provide success stories so that other people follow up. Along those lines, the Health Hub decided to, let's say, adopt the nature of being a gateway to Copernicus data so that we do not replicate or replace, but facilitate access to existing information, and the information can be raw data or products or applications or portals and visualization tools. To coordinate so that we bring together all the Copernicus activities that are under the umbrella of the environmental pillars into the application pillars, and in this case, the health application. So we filter this information for the health community to showcase and inspire, meaning that we want to show real-world success stories, how other people use the data and are applying them in their cases, in their needs, and of course to collaborate and engage. But at this point, you know, I should have started saying that it's the best of effort achievements so far. So based on your words, we hope that there will be resources and support to take this even further, so to collaborate and engage at a larger scale. So the 4 questions for the Copernicus Health Hub that I will try to reply today is what it is, why, how we plan to achieve what we have planned to achieve, and who it addresses and who it talks to. So the Copernicus Health Hub is a comprehensive platform. It's meant to be an interdisciplinary collaborative meeting point so that we use the best of available data and information to address health issues. And I should clarify that it's not only direct human health, but also semi and indirect effects, because we endorse the definition given by the World Health Organization that health is a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. So why was it created? We all know that Copernicus represents an excellent initiative for user-driven approach, but translating this wealth of data into actionable intelligence is a very critical challenge. And we want to be able to bridge this gap, to work into bridging this gap, and bringing together the environmental and health players to connect, share, inspire, and collaborate. Now, so far, how does it contribute? There is a strategy in place, but that's a discussion for maybe next GA. So for the moment, we highlight cutting-edge products from the Copernicus ecosystem that are pertinent to health. We showcase user stories of successful implementation, and we try to build an active community. And of course, we integrate community feedback on health application needs. This is a continuous process, and I should highlight here, take a look at our website. There is an open call for testimonials in which we want to listen how you have successfully applied data available from Copernicus services for health applications. You click on the link and then it will automatically take you to a form where you can fill with the necessary information. Who can contribute to or benefit from the Health Hub? I would say that the overall, let's say, idea is to be able to align our work with the mission and the objectives of many national, international initiatives, and to support the work already done by other organizations at European and international scale. And I've listed here a few of them that are pertinent to our work. And may I say that we already work closely with EA on the European Climate and Health Observatory, being an active partner of the community. Of course, it's very relevant for research and universities, industry and innovators. There are many cases of successful mobile apps that alert system for events on pollen, dust, and bad air quality. For policymakers and public authorities, of course, the media and general public, and this has also been a successful story through NCP, and civil society and NGOs. This is the first result of our effort to list the Copernicus program, the Copernicus services data that are relevant for health applications. Of course, you can see this on the website. So I just want to say that gathering and filtering these data sets and applications is ongoing work, and we do not replicate, as I said, the information of the data as they are delivered by the services themselves. So we highlight what aspects of the data, what components of the data are important for health applications. It's not our work to replicate the already existing work of the services or the availability of the data by the data stores, atmosphere, climate, etc. So here are some very recent examples of interesting data sets and applications that have been done with that, like the thermal trace app from very fresh out of the oven from the climate change service. The CAMS European air quality forecasts that include also natural pollutants and pollen, as said before. The three-layer information that has to do a lot with our mental health, and the Baltic Sea biochemistry analysis and forecast that supports the analysis of marine environmental quality, and you understand the potential impact on health because it it's very related to waterborne diseases. About the success stories and articles, yes, you see here a few of them. But as I said, please visit the website so that you share your stories. You can even, if you're not part of those stories, but you're aware of cases where successful use of Copernicus data sets has led to some nice applications or case study, you can fill that information for us and we can follow up on that. So there is a link there and you can follow that for the rest of the required information. And as already mentioned, and that's my last slide, in the other part of our work, which is the National Collaboration Program, we do have this in mind, and I was really glad to see this on the list of the how CAMS can support the Air Quality Directive by DG ENV. We do contribute to that with the National Collaboration Program and through the competitive grants call that is now under preparation. And I presented yesterday. And there is a dedicated action with how to bridge CAMS and health applications. And in the NCP direct assignments, direct contracts, we have a work package that Christina just mentioned to develop demonstrators for the energy and the health user community. And health is indeed very popular among our NCP countries. And with that, I would like to thank you, and we hope the next GA will be very, very different from this one in terms of the successes and achievements of the Health Hub. Thank you.
Thank you very much, Joni. Clear overview, and indeed, please go to the website and also please provide feedback, because we're now in the discussions of about the next phase of Copernicus, and we need to know, is this something that's really addressing user needs? Is it useful? Or do we need to change things a little bit? So please provide feedback as well. We have time for a quick question for clarification if needed.
Hi, great initiative, Stefan Brzezinski, UMedSat. Is this hub intended to encompass data from the Copernicus services only, or also data from Copernicus, meaning, for example, space-based products?
Okay, I just joined a few months ago, but my understanding is that at the beginning, this was planned for the whole Copernicus ecosystem. Currently, the first step is to include the Copernicus services data, and then depending on how this will be embraced and supported and how much further we can take it, we're open to discussing of changing these components or enriching them in the future. That's it. Thank you.
Okay, thank you very much. Then now it's a pleasure to introduce Eduard Escalona-Zorita from the EU Space Agency, EUSPA, who will talk about a different aspect of user engagement, focusing on turning CAMS data into business opportunities.
Thank you very much. I can see this podium is made for Czech people, for Spanish short people not so much. But I feel uncomfortable there. So thank you very much for the invitation and for the opportunity of presenting EUSPA and the work that we are doing, that we have been doing the last years in trying to help the Copernicus community. So I want to explain a little bit specifically what we have been doing and how you can collaborate with us or how we can help you. So my name is Eduard Escalona. I'm a Space Downstream Market Officer at EUSPA and somehow in charge of coordinating the market uptake activities of Copernicus within the agency. The agency, as it was introduced by Hugo this morning, is an agency for the European Union. We are based in Prague, actually, so for once I managed to come by metro instead of flying by plane, so it was a plus. But among different responsibilities that we have on the EU Space program in general for all the components like navigation, Galileo, EGNOS, GovSatcom, and within Copernicus, one of the main responsibilities is the market uptake of all the components. Specifically for Copernicus, it's focused on the private sector. So basically, we're looking at how Copernicus data from all the services, from all the data from the satellites can be used in downstream applications in different market segments. So we are looking at the whole spectrum of market segments. And how we do that is basically supporting startups, SMEs, but through a kind of bottom-up approach that you can see here, where we start with understanding the market, so with market intelligence, user intelligence, then moving that up to define what actions, what strategy we can do to support the adoption of the data, and eventually reach to a full adoption and penetration of all the data in the market. So the first step, as I was saying, is the market intelligence. It's one of our cornerstones where we start really understanding what are the market trends, what is the market size, the forecast, the growth potential. This is fundamental, the baseline where we know what is the potential real use of the data and where we have to focus our efforts on, basically as well to see what are the trends and the potential for more adoption. We publish these reports. We do a really comprehensive and quantitative analysis of all this data, and we publish every 2 years in this Earth Observation GNSS market report, together with other reports on technology that we publish every other year. And then this is complemented as well with the user intelligence, and in this case, with the private sector. So we here engage user communities in the private sector, meaning, for example, I don't know, energy companies, transport companies, real companies that on their own, they are not maybe direct users of the data, but they are eventually beneficiaries of the data, of solutions that are using the data. As well, we are engaging with private service providers that are really using the data and then are the ones providing the solutions for the private sector. And we have this user consultation platform that we do every year, in which we engage the community, we discuss user needs and requirements, and this is also basic to understand later how the data can really address these requirements and the needs of the users, of the private users, and to also analyze if there are any gaps, which can serve us later for informing the services if there are any improvements, any evolution that would be beneficial for the private sector, or this needs to be complemented by other type of data. Eventually, once we have all this information, we know which applications we can address, how we can help the communities to move from that theoretical analysis to a more practical one. And it's where we have been doing in the last 2-3 years, is supporting the implementation of pilots and demonstrators, which has been proven a very useful tool for raising awareness in the private sector communities, but as well to let them try and experiment with the data in addressing their actual needs and also in their operational environment. As well, it has been very useful for service providers to get in touch and do some matchmaking with end users, which sometimes it was difficult for them to reach them. So in this case, we have encouraged this more collaboration between let's say the final end user and some of the service providers. And as well, when we finish these pilots, we promote them, we show that it can be replicated, it can serve as lessons learned, so others can get inspired and try to do something similar. So here I have a list we have done dozens of these pilots. I put a list in the slides of the ones that are using CAMS data, or they are relevant more for CAMS. I will not go through them. You can see that there are in energy sector, in the urban development, in the health sector, in insurance and finance. There are really different sectors that can use CAMS data. Hopefully, I think the slides will be shared, so you can see them in detail. I just want to focus perhaps in 4. The first one in the energy sector was also mentioned, one of the beneficiaries of using CAMS data. This was a pilot that we did together with a Czech bank, basically a Czech bank that was doing investment in real estate, and they wanted to analyze if the return of investment of putting together photovoltaic installations in rooftops of industrial buildings. For that, they need kind of risk assessment of the investment, if it's worth and how much the yield of the energy will be. And the more accurate this prediction and of the forecasting of the energy that will be generated, the better, and so they can de-risk the investment that needs to be done. So using using CAMS data together with some climate change service data, there was a kind of assessment done together with the bank, and they managed to have some initial estimates that were, of course, much better than what they were doing before with some Googling forecasting. Another sector is the aviation sector. In this case, we worked with some airports. Some airports and communities, neighboring communities around the airports are interested in knowing what is the air pollution around the airports. And we built together with some service providers a platform in which they could use somehow part of the CAMS data of pollution and provide a map with 100-meter resolution on the pollution around the airports. And the intention is to use this as a kind of data-driven mechanism for decision making and as well for regulatory purpose if necessary. This is one of the most innovative cases we had in the health sector. This is, of course, looking at the private side of the health sector. We work with Teva, a big pharmaceutical company, which has a product for inhaler, basically for asthma patients. Which, as you know, the air quality, the pollutants, the pollen is very critical for their health and for the quality of life. And they had this digital inhaler that they are accompanying with an application, mobile application, that we help them include information from pollen and other parameters of quality. So patients can get notified when there is a raise of pollen, when they are forecasting different events that can affect their health. And this was very well received, and they are piloting now to put it operationally. And finally, the last example I wanted to show is in the smart cities, let's say in urban planning. So here we had two examples that we work with different cities in Europe. The first one was a simple application developed by the municipalities together with some startups on providing for cyclists and pedestrians paths that were greener. So not just a shortest path to reach a destination, but also provide information on what would be the greenest path or the healthiest or the most comfortable path to achieve a destination. And for that, they used the data from air quality and UV radiation together with other type of Copernicus data. And on the second case, some cities wanted to check their let's say the regulation that they do on the restricting traffic, for example, for low emission zones, and see the effectiveness of these decisions on regulating the traffic in the mid to long term. And they were using a pollution forecast as well from CAMS to do this assessment in several cities, including some other in situ data complementing and integrating them. So all this we are using all these pilots and promoting them through our website once they finish, and hopefully people getting more informed of the huge amount of possibilities that it has, not only for core users, for the public authorities, but also in the private sector. Also, I wanted to add this slide because you mentioned the Copernicus Hub and the Health Hub. So this is another of the hubs in the World Heritage, addressing World Heritage sites that we're implementing, that will be available by the end of this year, which of course it's as well incorporating data from CAMS together with other of the services. Here, for example, CAMS, it's data. It's being used or being advertised as how to consider this data for the impact it has in several specific sites, and there will be showcases of different specific use cases. And finally, just wanted to show, apart from this collaboration of pilots, that of course we collaborate with different service providers and users, and you can, it's open, you can talk to us, and we also always have opportunities. We also have the Cassini initiative, in which we are supporting the European Commission in supporting startups and entrepreneurs in develop solutions and in scaling up these solutions and in growing. There are different actions within Cassini, but I just wanted to mention now the one that are open, that is the Cassini Business Accelerator, which has a deadline on 30th of September. So if there are some entrepreneurs here, you can still apply. And also in October, we'll organize here as well in Prague what we call the Entrepreneurship Days. We do this once per year, and we put all the companies that have participated in different activities of Cassini, and they show their solutions. We have different speeches, pitching. We also put them in contact with investors. It's a very nice, young and active community that we want to support and engage for them to grow and continue scaling up. So just 5 seconds after my time, so thank you.
Thank you very much, Eduard, for this nice overview. I mean, CAMS data has always been very prominent in the public domain, and the uptake by private sector has always been a bit of a challenge. So it's really nice to see this more concerted effort to really see where CAMS data can be used for commercial activities. So thank you very much for that. Any questions? Leonard. Tangled up in.
We all feel a bit entangled sometimes, so that's all right. Thank you very much for this presentation. I think it's very interesting that we have showcases. And it's always like from the showcase to the scalability. So that from the demonstrators and pilots that you are seeing here into the Cassini, which is really what I would like to hear a bit more. How many, what are they using? It would be very interesting to know that. But how much do you see that the pilots really feed into? Is that a good way, or are there other ways that we need to do to get into this competitiveness and scalability that we are looking at? Is the pilot and demonstrator approach a good part, or are there other things to look at?
There are obviously more things to do. This is just a kind of first step so that end users can start playing with the data and understanding what the data can do for them. Of course, these users, they will see a kind of solution that is tailored for them. But then we need to scale up these solutions in a way that it's not always one solution for so a different solution for another. And I think this is one of the main problems, the fragmentation in the demand side. There is not kind of standardized solutions that Earth observation community can do, and then all the end users can just use and apply. It's not standardized so far. So right now it's more an effort of awareness, of getting them more involved, but there is a next step that needs to be done in order to let's say, standardize a little bit more the demand so that the solutions provided by the service providers, by CAMS, can fit more in a general way rather than always having to tailor to each specific end user. So there is still a lot of work to be done, but I think with these pilots and demonstrators, it's the first big step that they can get interested. Some of the users that we have been dealing with in these pilots, after that, they did their own tender themselves to scaling up what they tested with us. So that is is a nice step to start, in our opinion.
All right, thank you very much. I'm now handing over to Christina, who will manage the panel discussion. I think, Eduard, you can stay.
Here, yes. Okay, in this panel we are going to give the floor and we are going to listen to some users at regional level, at national level, but also at international level. So I'm glad to invite on the stage, Eduard is already here, Michele Stortini. Yes, Michele Stortini, he is from the Regional Environmental Agency of Emilia-Romagna in Italy. and he's the head of air quality forecasting unit. Then I would like to invite on the floor Stefan Nordmann, German Federal Environmental Agency, UBA, from Germany. And then online, I have Juliette Laurent from the Climate and Clear Air Coalition. Juliette, yes, I see you there. Welcome. So the idea of this, and then we have obviously Edward that he's here and again with us to respond to some questions that are a bit connected with the question done before by Leonor. So an important tool that is used by USPA to collaborate or to engage with their community is the user consultation platform. And you use this tool also to receive feedback and let's say user requirements from the private stakeholders. Based on this direct engagement with the private sector and using this platform, but also using this pilot project that you briefly mentioned before, can you focus a bit more on which are the downstream applications that are more important in this domain, in the private sector, and how somehow we can collaborate to fit a bit this gap between what we are doing and what you are doing with the private sector.
Thank you for the question, Christina. I think we have seen it and we have discussed these main sectors throughout the morning, and this is in line with what we have seen as well. The sectors that in the pilots, when we approach the end users, first we look at the whole spectrum, we discuss with them what are the needs, and then which are the use cases that are more interesting. And it always goes back to two main areas. One is in the energy one. As I was mentioning, actually we have almost 7 pilots that we have done already with different energy companies. And one of the main use cases is the forecasting of the energy production, but not only that, also the forecasting of the demand, which can be maybe more related to C3S. But it's very important to estimate the amount of energy that can be generated, mainly with renewables, because it's not a stable production of the energy. So it's very important for energy companies to know how much energy is going to be generated in the future from different sources, from wind, from solar, and specifically for solar, because it's one of the main ones we have in Europe. This forecasting for the grid balancing and to know when this lack of energy will need to be compensated by others or how much it will be generated is very important. So this accuracy and the use of CAMS radiation data or aerosols to information, it's really extremely important. So energy sector, of course, as you know, it's one of the sectors, and the other is health. We have discussed about health. And health as a transversal level. So not only in the health sector, but everything that is related with health, that it's not only for the health sector, but I was showing, for example, the one on the air quality for transport, for airports. It's related to health. I mean, you want to know how much is the pollution for health reasons, but the sector that is monitoring that is the transport sector. On the use cases we showed on the urban planning, it's as well, it's for a health related objective, but it's the let's say, municipalities or the cities that are, or the urban planners who are using this data. So there are different sectors that as well can benefit from all this data. And I would say these two areas, energy and everything related with health, are the most, the ones that have most potential in the private sector.
Okay, thank you. Then let me address the second question. You have already shown some successful pilot project, but as was already remarked before also by Leonor, moving from this pilot to something that is really commercially viable or really used at commercial level is not so easy, not so straightforward. From your perspective, from USPA perspective, which are the main non-technical challenges that you have to achieve and you have tried to also to solve?
It's good that you mentioned non-technical, because I would say that technically, of course, they are always requesting better resolution, better visit time, better forecasting. But technically, data, I think, is very valuable already, and it's very useful. But non-technically, there are always challenges, and that's why we don't see a widespread adoption right now. One of them is of course, the awareness in the end users. They don't know so much about the data and the benefits they can obtain, mostly because they will buy solutions for their problems that address the problems. They are probably an end user and urban planning is not going to directly buy, I don't know, aerosol optical depth forecast directly themselves, but they will buy a solution that maybe uses that data. So what we are trying with these pilots is to make them aware that solutions can be built based on this data, but what is important for them is the final solution. This is one of the aspects. The second one is that most of these users are, it's very nice when we see platforms that are showing the data. You can download the data, visualize things, but most of these users, they have their own platforms. And they don't directly want to go to a different platform to visualize or manually check the data that then they have to incorporate somewhere else. They would like an integrated system on the platform that they're already using. So the ability of integrating this data directly, so let's say this last mile of integrating this data in their own operational procedures or platforms is something that is still missing. It's not done directly. We are trying to see how this can be more standardized, or maybe working with some multipliers companies that are providing these platforms so they can incorporate the data. But I think right now it still remains an issue of how to use this data directly in the platform of the end users. And finally, I would say maybe we see that many of these solutions are provided by startups, SMEs, which is a risk for themselves. They can maybe participate in pilots, fund themselves, and do some developments, but to scale up, they need further funding. They need something that they can rely on more long term, do further investments, and for that, we're trying with Cassini to help these companies to grow, to put them in contact with investors, so they can have more sustainable development. But right now, because these solutions are innovative, so many are provided by SMEs, mostly in Europe. So I think there is also a gap that we are trying to fulfill with Cassini, but we should help more these companies into develop these solutions and scaling up a bit more.
Thank you, Edward. Now we move a little bit more to the institutional side, and we are maybe a bit more familiar also with the context. And I would start with Michele Stortini, representing Emilia-Romagna region. And I would like to hear from him really the end user perspective in this context. You are deeply engaged with CAMS product ecosystem. You are involved quite a lot in the CAMS NCP, and you have also long experience in using CAMS products and CAMS services in general. Could you share with us some concrete examples on how you and your institution currently use CAMS products in your operational day-by-day work? This is an important aspect that I would like you to underline.
Thank you, Cristina, for this answer, for this question. Well, first, I would like to know that in Italy, the legislation delegates lots of responsibility to the regional level, and so, for example, for our environmental agency, which is in the north part of Italy, in Po Valley, it's a very huge job to cooperate with other regional agencies in the Po Valley, because, as you know, pollution is no border, and so it's very important for us to collaborate with other regions. And this is it's a specific of Italian legislation, Italian organization, and we try to, in this way, we try to operate this kind of experience in SCP. In general, in our region, we use CAMS forecast ensemble as a boundary condition for our operational model. And we use model at two different levels, one at national level and also in regional level. Regional level now we are run at 3 kilometers of resolution, and we are skipping in, we switch off in, I think at the end of this year, at 1 kilometer resolution in our region. And another thing that we, another type of data of CAMS that we use is forecast pollen and speciation data, and we compare this data with our measurement in situ, just to have an idea about the pollen, because it's the first time that we start with pollen, and the pollen means like, we speak before about health, human health, so pollen is involved in human health, etc. And we use all policy tool only for internal use, because it's not so easy to use this kind of tool to explain the real how manage the data of policy tool for people who are not expert. I mean, for example, for politician people who ask if the result of policy tool are true or not. I know it's not a good question. I mean, for expert people also know that it's not a really question, but politician people say the number is a real number, is true or not. And when we make some comparison between policy tool, which is at the European level, with measurement level, which are local level, obviously they are not, sometimes there's not a comparison between this number, and they ask us which is the true number. Say it's not a good question, but we have to try to answer this question. So it's, for us, it could be different, if not so easy to use a policy tool. That I think this is a very good tool for experts to understand which are the situation, and also the idea at the European level, etc. And in our experience, the use of CAMS boundary condition are very useful. For example, we increase our performance for ozone and for PM10, because it's more easy to capture the dust event if you use Copernicus data, etc. So we are quite happy to use boundary condition from ensemble model.
Thank you. Another question for you. Let's say that now, let's imagine that you have the opportunity to co-design together with us, together with Laurence, a new CAM service or a new product, really tailored to your needs. Which are the features or aspects that you would like to prioritize? So let's say a couple of priorities from a regional end user.
It's a very important, very difficult question to answer. Well, first try to say the technical aspect. For example, the data available time. Actually, the data are available at 10 universal time, more or less in the morning. For our region, we have to prepare forecast at 10 o'clock at the local time. So it's 8 o'clock in summer and 9 in winter, universal time. So we have to use the forecast of previous day. And it's possible, I mean, the question is possible to have data error? I don't know, but probably this is one question. It's very, it's technical. Another technical question is about the possibility to download data. Now, we are, I think that 2 days ago, we have received a mail that it's possible to use data using FTP service, and we would like to test the service as soon, I think, in the next days. Because actually, the Python API download are very slow, so it's possible. But for example, I hope that the new way to download data could be better solve this question. It's very smooth. Another technical question which is very important, I think, is about the number of speeches and the number of level that now are involved in ensemble model. It's possible to increase the number of the level in vertical or increase the number of the speeches. Okay, it's not so easy, I suppose, but with just a question. But I think that more political problem is about the policy tool. Because the policy tool, I think it's very useful, it's very important, it's very interesting, there are lots of data, and the question is, could be using NCP or other kind of product or program help people at national, at regional level, for example, for a regional agency, to implement the policy of the methodology of policy tool at the local level to help us, because I know that there are some problem of supposed to be problem with IPC resources, probably. Another is about the methodology, because, as you know, I mean, regional agency have only few people who work in air quality model, because they have to work at lots of aspects. So the idea could be if CAMS can help people to increase to have the possibility to implement using local data policy tool. Like, I know that it's very I mean, it's very hard question, it's a very useful question, but okay.
I saw Laurence taking note. I don't know if you want to provide question now, a response now.
I would like to know that about the other question that needs that we asked you about the possibility to change data. We use European Weather Cloud, and we would like to thank you that we have to use this kind of effort to exchange data, because for us it's very useful, and we are very happy to use the Weather Cloud to exchange data used in the work of national program.
Thank you. Are you going to reply now or tomorrow, maybe during the fight? Okay. Thank you, Michele. So let's now move to a national level, and we have the German Federal Environmental Agency representative, Stefan Norman. He is the leader of the unit General Aspect of Air Quality Control, and currently is working on a topic like modeling of the air quality under the EU Ambient Air Quality Directive, or under air quality projection under the NEC directive. So I have a couple of questions for you, because indeed you are also another end user that is, sorry. Yeah, no, I'm trying to, okay, yes. As I said, you are representing a national end user that is deeply engaged within the CAMS product ecosystem, and you have a long experience on using our data. Again, can you please share some concrete example on how you and, in general, your institution currently use CAMS product in an operational, day-by-day work?
Yeah, thank you for this question. So we actively use the CAMS data since several years and are very happy that such a service is available continuously. To give some examples, the first one is the forecast. So we use the CAMS regional ensemble forecast. We started to work with the data in 2018, and then come to an operational state. So taking the data, make a bias correction, and then directly use this data to inform the public in 2020. We started with ozone. Now we have also the other pollutants in our offer, and the data is then provided to the public via internet, via web application, and also via app. And this app has now let's say, over 200,000 users which are working or which are informed about the air quality. And users can also download the data via app, API, and so on. So there is a lot of people using this data. And we also, in a second example, work with the data as boundary conditions for our national modeling. So we take the CAMS analysis data and took the concentrations at the boundary of our domain and downscale it to 2 by 2 kilometers. And this we do on an annual basis. So every year we make such a simulation, and we hope in the future that this data is also used by our regional authorities. This is somehow similar to the Italian case, so that the regional authorities also use our simulation results on 2 by 2 kilometers for their own simulation in higher resolution for their regions. And sorry, one last point.
Yes, sure.
And the last one is that we use also, of course, the CAMS regional emissions, also very important data for us. So we, of course, have our national inventory, but at the boundaries, at the surrounding of Germany, we use CAMS emission data to know what, or also to compare our national inventory to other inventories and to see some inconsistencies and so on. Yeah.
Thank you. And also for you, the question, and Lorenzo will continue to take note on this, which are, let's say, some key developments for innovation that you would like to see inside CAMS that can really address effectively your needs at national or regional level?
Yeah, so many things were mentioned yesterday. So I really like the idea of a dust viewer and also to make the data available which comes from natural sources, also biomass burning. But there you also have to take or to look what the implementing act will say about natural sources. So what is the real definition of natural sources? So if it comes from a natural area, like the desert Saharan dust, then it's a clearly natural source. But if it's from an arable land, then it's no real natural source. So we have to be a little bit more precise there maybe. And also the planning aspect, which was mentioned by DG ENF in the morning, is also very important. So the NEC directive gives some projections of emissions in the future. This would be very helpful, and this would also be used or needed maybe by the requirement of the new air quality directive when it comes to roadmaps or something like this. So then it's also important to have emission projections, and this would be some important outcome maybe of CAMS. And maybe one last thing, Sentinel-4 data, I see there would be maybe some very good information about the temporal distribution of emissions in future, and this could also be a big topic for CAMS. Thanks.
Perfect. Thank you very much. Sorry, I'm not a good timekeeper this time. Last panelist in this discussion is Juliette Laurent, as I said, from the Climate and Clean Air Coalition. She leads the development of the Air Quality Management Exchange platform. Juliette, you are a kind of newcomer in this community, so welcome, albeit only online. I know that you have some slides, and I will ask you the question, and feel free to use the slide as you prefer, trying to keep the time a bit short. So can you briefly introduce us the Climate and Clean Air Coalition to the CAMS community? And we would like to hear about the mission, the key initiative, and which is the role that this coalition is plays in advancing air quality and climate action at global level, this case.
Sure. Thank you, Christina, and thank you for having me. Sorry I couldn't be here with you in person. Can you just confirm that you see my screen?
Yes, yes, you can.
Okay. Thank you. To give you first a brief overview of the CCAC, or the Climate and Clean Air Coalition. So it's a UNEP hosted initiative that was launched in 2012, and it's a voluntary partnership of countries, but also NGOs, philanthropies, and other UN entities. And actually, it's the only global partnership who is dedicated to tackling super pollutants. So namely tropospheric ozone, black carbon, methane, and HFCs, as well as nitrous oxides. So the reason that the CCAC focuses on those super pollutants is first because, as you know, their global warming potential is much higher than that of CO2, and they're responsible for more than half of the global warming that we've seen to date. And also because most of them are short-lived, except for N2O, cutting their emissions now can have real benefits in terms of preventing near-term warming. The other reason we tackle those super pollutants is that mitigating them can bring a range of co-benefits, obviously in terms of climate, in terms of avoided warming, but also protecting the cryosphere from the impact of black carbon, but also for human health protection, because as you know, many of those super pollutants are also air pollutants, and we know that air pollution is the largest environmental threat to human health. Finally, we also look at co-benefits in terms of food security, and this is primarily related to the impacts of tropospheric ozone on crop yields. So the CCAC works across three pillars. First, we engage in high-level political advocacy with global leaders, really to raise the ambition on the super pollutant agenda. We also work closely with our scientific advisory panel, producing assessment and briefs that really provide the scientific basis and case for integrated climate and cleaner action. And finally, we also directly fund country-driven projects, providing support to ODA-eligible state partners through capacity building and technical assistance, but also support to the development of national policies and implementation of effective solutions. So in terms of our sectoral approach, we focus on six key sectors, which are cooling, household energy, waste, agriculture, fossil fuel, and heavy-duty vehicle and engine. And we do that through our sectoral hubs that gather key experts and stakeholders in those different sectors. Moving on to our work specifically dedicated to air quality. So in 2024, the CCAC launched its Clean Air Flagship Program that will run over 3 years with the overall objective to raise the ambition and catalyze action on clean air by supporting international cooperation and capacity building, but also engaging with the private sector and mobilizing finance. And so also in 2024, the UN Environmental Assembly adopted this resolution 610 on the promotion of regional cooperation to improve air quality globally. And so as part of this resolution, member states mandated the CCAC to deliver on two initiatives. The first one is a global online platform for information sharing on air quality management. And the second is an Africa Cleanup program. So on this online global platform, it's called, as Christina was mentioning, AQMX, so the Air Quality Management Exchange Platform, and it was launched by CCAC and its partners for International Clean Air Day of 2024. Really, our objective with AQMX is to provide a one-stop shop for knowledge and guidance on air quality management. Our priority audience is air quality managers, whether at the local and national level, but really with a strong focus on air quality managers from low and middle income countries. And so on AQMX, we have two key components. The first one is this curated guidance that we have developed for 8 areas of air quality management, So starting from monitoring emissions inventory, but also how to carry out a health impact assessment, how to engage with your public and so on. And the second key component is this online library with more than 900 trusted resources. So anything from reports, scientific publications, but also tools, models, databases that can really support the work of air quality managers on the ground. And so second key activity, as I was mentioning, is this launch of the Africa Cleanup Program, which stems from the integrated assessment of air pollution and climate change for Africa. So this assessment was published by the CCAC in 2022. It highlights 37 priority measures across a range of sectors, and it was endorsed by the African Union Commission in 2023. So last year at the CCAC Ministerial, 1 million USD were pledged towards the implementation of the Africa Cleanup Program. And a few months ago, we announced the ACAP champion countries that will be really at the driver's seat for this program, which are Morocco, Ghana, Kenya, South Africa, and Madagascar.
Okay, thank you, Juliette. I think that you had the opportunity to investigate a bit about the CAMS service, the CAMS products, and if you can tell us which are the products that you can highlight as of particular interest for the goals of your coalition, and how you see a kind of collaboration between CAMS, ECMWF, obviously, and your institution.
Yes, so on the question of why the CCAC is interested in this issue of satellite data for air quality management, first of all, I mean, even if our focus really is on action and mitigation, we do recognize that there is an air quality data gap, and especially in Africa. There's a World Bank report that was published a few months ago, and that highlighted that across the whole African continent, there's only twice as much reference grade monitoring stations than in the city of Paris alone. And at the global scale, it's actually only a minority of countries that have access to reference grade continuous monitoring stations. And this is because, as you know, those stations are expensive to purchase and to maintain in the long run. So what we see more and more with the state partners that we're engaging with is really hybrid networks with a combination of one or two monitoring reference grade monitoring stations in combination with passive diffusion tubes and increasingly local sensors and satellite data. And so at the CCAC, we take an agnostic approach to air quality monitoring methods, as long as the advantages and limitations of each of those methods in terms of cost, accuracy of data, spatial and temporal coverage, as long as those limitations are well understood by data users and policymakers. And so really, how can low and middle income countries use satellite data for air quality management? We see two situations really. First, in those countries where there is no ground-based monitoring and essentially no air quality data, the usefulness of remote sensing data for us is really to establish first a baseline knowledge of air pollution levels and also to identify hotspots at the local or national level. And really, essentially, it's about convincing decision makers that they have an air pollution problem and that they should take action with priority on the key emitting sectors. And then for the second category of countries where there is some ground-based monitoring, here as well, remote sensing data can be really helpful to complement the monitoring network in terms of spatial coverage, of course, but also the type of pollutant that is being monitored. We know that very often when countries have a choice, when procuring equipment, they will prioritize PM, maybe NO2, but other pollutants such as ozone, for instance, tend to be overlooked, and there is a real lack of concentration data. can also be useful to strengthen modeling and capacity and forecasting capacity on the ground, especially in regions who are highly impacted by sand and dust storms event, to test policy scenarios and support the implementation of really effective mitigation policies. And the last point I wanted to emphasize is that we see also an opportunity for remote sensing data to support international cooperation on transboundary pollution. We know obviously that air pollution knows no border and that really cooperation between countries is critical, following an airside approach to actually bring results in terms of bringing the concentrations down. But what we see very often is countries having questions on data comparability or even questioning the reliability of their neighbors' air quality data. And so we really see opportunities for satellite data to address those concerns and to support regional collaboration for clean air. And so to conclude, I just wanted to say that at the CCAC and more generally within the UNEP world, we know that there is really a wealth of data and products being made available at the global scale through remote sensing. But at the same time, we recognize that among the air quality managers from the global south that we engage with at the CCAC, there is still a relatively low uptake of this data and products and limited understanding of what can be and cannot be done with them. So really for us, the question is how can we bridge that gap between data providers and the end data users from the global south? And how can we ensure that satellite data and products are easily accessible and usable by air quality managers and policymakers in low and middle income countries? So that's a conversation that we are really interested to have with stakeholders in the field. We're also exploring how we can develop specific guidance on the use of remote sensing data for this AQMX platform that I was mentioning, and maybe also envision some sort of training opportunities for AQMX users. So I'll stop here and thank you again for your attention.
Thank you, Juliette. And indeed, I think that in CAMS you will find already some responses to your question, and I hope that this first presentation during the CAMS GA is only the starting point for this meaningful collaboration with the coalition. So I think that we can close this session. Sorry for being a bit late. I hope that you enjoyed the discussion, and thank you to our panelists. We can go downstairs at the 3rd floor for the lunch, and then we have to come back here at 2 o'clock. Ah, 2nd floor, sorry. And then we have to come back here? 2:15. Okay, thank you. Thank you.
All right. Hello, I think we will start now, just to be sort of on time. So welcome to this session on Earth observation for CAMS. My name is Maria Bardal. I'm the CAMS program officer at the DGDAFIS, and I will lead you through this session. So satellite observations are really at the core of Copernicus. And they're also a driver for service development. This is also a big year for atmosphere missions with the launches of Sentinel-4, Sentinel-5A, and Microcarb. So in this session, we will get an overview of the current Earth observation landscape for atmosphere monitoring and how this is taken up in CAMS, and also a bit about future plans and developments. So we will start with the presentations and then finish with a short panel discussion, but we will have a short Q&A related to the presentation right after each presentation. So we will start with the presentation from Richard England, whom you know from the previous session, and also from earlier in life. He is the Deputy Director of CAMS, and he will present ongoing work and future plans for uptake of Earth observation into CAMS. The floor is yours.
Thank you very much, Maria. Yes, it's up there. So yes, I will give a brief overview of Earth observation within CAMS. I can't be super comprehensive, but I hope I included all the relevant parts. If not, my apologies. Does this work? Oh, this one, sorry. Right, so Earth observation and CAMS. Well, we've heard already today that CAMS is part of Copernicus, which is part of the space program, so no-brainer. I was preparing this presentation, and it was sort of interesting, because if you look at the ESA and EUMETSAT websites about Copernicus, you get the left graphic here. Lots of satellites orbiting the Earth. If you look on the right, that's what you see when you go to the services, the homepage of the service explaining what Copernicus is. Yes, there are a few tiny satellites, but then there are the services. But as Sunko already explained this morning, it's really key of the Copernicus program that we have these things together in one program. And that's really the added value that we bring with the Copernicus program. So I think it's really important to emphasize that again and again, also in the international context. So Copernicus is an Earth observation program, building satellites, trying to support in situ measurements where possible, and having the services to provide added value. So within CAMS, so this is a standard graph we use, graphic we use to show how CAMS works. This doesn't include all the services we have, but it's really what's at the core. So we have our modeling systems, global and regional, but of course they need input. And on the right is what we talk about in this session, which are the satellite observations and the surface observations we use as well. On the left, other inputs like emissions, wildfire emissions, which are actually constrained by satellites as well, and the European emissions for the regional models. So we really try to combine these modeling activities with the Earth observation we have. So for CAMS Global, the way this works, and I'm probably preaching to the choir, but we have lots of observations, and I'll come back to that in a moment. And here's an example of tropomi carbon monoxide observations, what we get within one day. We assimilate it in the global system with data assimilation. We do this actually every 12 hours by using the forecast from the previous day or the previous assimilation cycle, combining with the observations in clever ways to generate the analysis, which is then the starting point for our forecast. And we do this again and again. And every time we try to explain this to people who are not familiar with how this all works, it's basically yesterday's forecast adjusted by today's observations to provide tomorrow's outlook. It's that simple. In practice, of course, there's a lot of complications there. But it's key to merge the information we have together. So what satellite observations do we use? Well, this is for the global system. And this is the number of satellite instruments we assimilate every day. So this is currently close to 90 different instruments, not just looking only at atmospheric composition, of course also the meteorology, the land surface, etc. But it's 90 different instruments, and every day we assimilate 40 million observations. It's a lot, but it's what makes the system tick and what allows us to provide really good forecasts. And this is often not really seen when you talk about data simulation. Yes, we use these satellites, Sentinel-4, Sentinel-5, all very good, but there's a lot more going into these systems. And here we really benefit from what has been done in numerical weather prediction for several decades to really make the strongest atmospheric composition system we can. To zoom in a little bit, what does this mean for atmospheric composition? This is a nice graphic showing the satellite data we've been using over the years for ozone specifically, from 2015 onwards to well, what we expect in the coming years as well. And this is for the daily operational forecast, the data we've been using. So again, you can see there's a lot of different instruments, in parallel, but then also trying to have overlap so we can make sure we have consistent forecasts over time throughout the years. And you can also see that for the coming years, there's quite a bit of observations waiting for us to use. And it's really important, both in terms of having overlap between different instruments to make sure we can stay consistent. We apply bias correction, for instance, but also to have instruments in parallel, because they don't always observe the same thing, the same altitude or the sensitivity, but also if one instrument fails, we want to have another one to make sure we still have a good analysis. Also in the global reanalysis, there's a lot of data going in there, and this is a graphic thanks to Antje, who put this together, that shows the instruments we will use in the global reanalysis. I'm not going to go into detail, and I know you can't read all the names from where you are sitting, but again, it shows the satellite data we use for atmospheric composition only. So we also will use the meteorological observations, as I showed earlier, throughout the reanalysis. And here the really tricky part is, how do we make a consistent reanalysis? So we know that the observing system is changing over time. So how do we deal with that? And I mentioned already bias correction. We try to make sure the instruments provide consistent data, at least at the assimilation stage. But this is really one of the big challenges for atmospheric composition at the moment. Having a consistent data set for all the species we are interested in with the changing observing system. Then going to a few other services. So solar radiation is another service of CAMS where we make direct use of satellite observations. And here again, also it's a combination between model information and satellite observations. So for instance, aerosol, ozone comes from the global system, but then we use MSG and Himawari at the moment to get the solar radiation right. And we provide this on a daily basis in terms of time series, but also these really nice geographical distributions of incoming solar radiation, in this case for MSG. So really important to have satellite data available there, and also to have them in the future. For instance, MTG, the next generation of geostationary data, is important there. Greenhouse gas flux monitoring, another part where we use satellite observations. Most of these inversions, atmospheric inversions, to look at CO2, methane, and N2O fluxes rely on in situ data, but we're bringing in more and more satellite data there as well. The example here is for CO2, thanks to Frédéric Chevalier, where in blue we see the estimates of the net fluxes for large countries or large areas in the world. In blue for in situ observations, but then in yellow we also have now the satellite constrained fluxes. So this is really nice to see that here we can now move towards using satellite observations and actually being fairly consistent in the estimates. For methane as well, here we use GOSAT, and I think now also Sentinel-5P in the operational product to constrain the fluxes for methane. This one has been mentioned today already, but one of the latest service additions as part of our ramping up of the emission monitoring capabilities we promised to deliver. So this is methane hotspot monitoring, so looking at facility level emissions using Sentinel-5P. So these are really large emitters where we have larger scale visibility of these emissions that we can pick up routinely and now really show nicely on the CAMS website. But we're also now starting to work with some commercial companies as part of the contributing missions program of Copernicus. So this is really nice. It's a bit of a challenge because it's a different way of working if you work with commercial data instead of public data. But yeah, we're really keen to get this going and make use of data from GHGSat, Absolute Sensing, and Satlantis. Fire emissions I already mentioned. Here again, we use satellite observations to look at the fire radiative power that we then convert to emissions on a daily basis. So again, really important input from satellite observations. traditionally been using MODIS, but now we have this transition towards using FIRS, which is also an American instrument. I missed Sentinel-3 here. How could I do that? Sentinel-3, and then also geostationary Severi goes and Himawari. So combination of satellite observations that we want to bring together to have the most accurate emission estimates. So that's sort of what we are using now, and apologies if I forgot something to mention something, but it's clear that there's a lot of satellite data driving the services, and that's exactly what Copernicus is about. But there's more to come, and it's actually a lot more to come. We have heard already today about Sentinel-4, Sentinel-5 that have been launched, CU2M in 2027. But also don't forget the other instruments on some of these platforms, like the METOP second generation and the Meteosat third generation, which includes instruments like YASI. Is it NG, next generation, or SG? I don't know. Yeah, the next version of YASI with more capabilities on the geostationary, the infrared radiation sounder, IRS, 3MI for aerosols. So there's a lot more to come. And then, of course, already mentioned today, microcarp, and we'll hear more about that instrument in a moment, and goes at GW. And to make you really scared, this is sort of the potential just for CO2 and methane. This is what's either out there or being planned. So both public missions and commercial missions looking at different scales. So yeah, we need to find a way through this. What can we use? What is good to use as part of an operational program? And how do we make sure everything stays consistent? And this is not trivial. At the same time, it's incredibly exciting, of course, to have this data available. So I'm not complaining at all. Then my final slide, just let's not forget about the ground-based observations and the aircraft observations. They are critically important for the service. To assimilate the data, for instance, regional models, to evaluate what we do with the forecasts. And we try to work with several of these networks, try to support them, but there's a lot of other data out there as well. And some of it actually is at risk at the moment, which is not a good place to be. But yeah, we'll see how we can make sure we have the data we need. And with that, I'd like to thank you.
Okay, thank you, Richard. Any burning questions for Richard? No. Okay, thank you. So then let's move on to the Copernicus Space segment, and let's start with a representative from ESA, Michael Eisinger. Here I see the EUMETSAT presentation. Okay, well, yeah, there it is, right presentation, great. So Michael joins us from the ESA Climate Office, where he works on atmospheric variables. And yeah, will tell us a bit about the Copernicus Space segment in the Atmos family and their work at the Climate Office.
Thank you. So I will actually spend a large part of my presentation on what we do in our climate team, and then at the end I will specifically mention the new Copernicus missions and upcoming Copernicus missions. So we are observation provider. I'm actually privately also a data user of CAMS because I regularly look at the aerosol forecast, and I had a situation 2 weeks ago where at the end of a working day I saw that my bicycle was very, very dusty. So I immediately went and checked, and indeed we had some Saharan dust coming around over the Atlantic Ocean via Ireland to the UK. In the Climate Space Program, which is the current 6-year program of ESA, we provide the physical evidence basis for climate via the essential climate variables. We support the Paris Agreement via monitoring the relevant parameters. We link to the modeling community and we look across the ECVs, combining ECVs, essential climate variables, look at tipping points, and we have new areas as well, which I will come to in a moment. And the basis for all this are the requirements from the Global Climate Observing System, GCOS, and the World Climate Research Program, WCRP. So GCOS defined 55 essential climate variables, and of these 36 benefit from space observations, and we generate 27 in our program. And you see the atmospheric ones in the top left and top right in the yellow boxes, so the light blue parameters. So each of these parameters basically corresponds to one project which we run. And just to give you a little update of what's currently happening in the cloud, we are now in the next phase focusing on clouds over the Arctic, which are specifically challenging. And we are very happy that we have a new mission called the Arctic Weather Satellite with a microwave instrument for ice clouds, which we will integrate into this activity. In the water vapor activity, we added validation using radio occultation measurements from the Danish Meteorological Institute. We are very happy about this as well. Then we have the aerosol study, where we will bring in now in the next phase profiles from EarthCare. The greenhouse gas activity, so that's the methane and CO2 activity, where they further refine the existing algorithms and they go to also higher spatial resolution. Then we have ozone, that's both the stratospheric ozone looking at ozone recovery and the tropospheric ozone looking at pollution, using various sounders, a large number of satellite instruments. And there we are specifically looking, one of the new things, at the geostationary satellites, the American one, Tempo, and the Korean one, the GEMS. We leave the Sentinel-4 to EUMETSAT, so we're complementary in that sense. Then we have the what's called ozone and aerosol precursors, so that's NO2, SO2, and other things. And other long-lived greenhouse gases, which is more an exploratory study where we look at things like chlorofluorocarbons and the hydrogenated versions of that. Here, this is about the linking the observations with the modeling, and I want to draw your attention specifically to the right hand side. As part of our activities, we are also creating forcing data sets for climate models. So CMIP, the Climate Model Intercomparison Program, covering stratospheric aerosol optical properties and volcanic emissions into the stratosphere, greenhouse gas concentrations and ozones. These forcing data sets are long-term data sets, so they cover more than just the satellite era. They go back to the past using historical data, and they also cover projections for the future under defined scenarios. As you know, climate change is accelerating, and that also means that they have to change the way they are updating these forcing data sets. In the past, this happened basically once per IPCC assessment cycle, and now they are probably going to one update per year because reality is changing so fast. This is listing basically new projects which we have started over the last year or so. And in parentheses, you have the number of projects. So in total, 25 in various areas. So there's 4 projects on new ECVs, new essential climate variables, 6 projects on cross ECV, where you combine climate variables, 5 on climate tipping points, 4 on cities, 3 on biodiversity, and 3 on health. There's only very few of them which are related to the atmosphere, and they will point them out. In the health area, we will start a project. It has not yet been kicked off, but it is going to be kicked off soon, which has a regional focus on Lombardy, north of Italy, the area of Milan. You have seen this morning that this is basically the most polluted region in Europe, and we will be working with DLR and the emergency services from Lombardy to study the impact of rising temperatures and air pollution on emergency calls. So we can make use of a database they have of emergency calls, and they will try to correlate it with heat waves and with pollution events. I mentioned the cross ECV projects. The one I want to highlight is the one in the middle, in the bottom, which is on aerosol cloud interactions. And there we are specifically looking at glaciation of clouds by dust, so the impact of dust on cloud glaciation, and on the aerosol indirect effect on liquid clouds. I will go quickly with Medusa because Ilse has a presentation on that tomorrow, and she knows much more about this. But basically, this is Richard mentioned this large landscape of methane instruments, which has really exploded over the last few years. Even instruments which were not built to measure methane are now measuring methane. And this is basically trying to survey this landscape and have a look at how valuable these satellites are, and basically bringing a bit of order in the mess of available data. So this is looking. This is one angle to look at it. Another angle in a different project is basically going to try to derive practices to have traceable and robust methane emission data. There are currently what's called common practices, and this project, which is led by Leicester University, is trying to improve that and arrive at good practices, core good practices. We are not saying yet best practices, but good practices for characterizing methane plumes. And it is particularly looking at a maybe a little bit understudied region so far, which is South Asia. I cannot possibly not mention Earth Care here. This is specifically in this community relevant for anyone interested in aerosols. So we had the launch of Earth Care last year. We had a very successful commissioning phase. We are absolutely happy with the performance of the instruments. They are all like outperforming expectations. And one very important piece of news which we got in the last month is that we have a longer expectation now for the lifetime of Earth Care. So this was supposed to be 3 to 4 years, but we are now confident updating the estimates that we have enough fuel for about 10 years. So if everything goes well with the instruments, this becomes a this becomes a very relevant instrument for aerosol monitoring as well, because you get the global vertical profiles, and you see here a nice example of a combination of cloud and aerosol measurements from the LiDAR, and we have unprecedented sensitivity for aerosols with this instrument. One more so this was by the way a first flight example. So this was without any fancy processing. This was just data as we got them very early in the mission. And a more recent example, which I find very interesting, is this one from the Canadian wildfires this summer. I think it's the third year that we have very extreme wildfires in Canada, and here we have a case where the aerosol was lofted above the tropopause into the stratosphere, and we can see on the right clouds from the wildfire, smoke clouds as high as 17 kilometers. So we had like pyrocumulonimbus formation in Canada, which was also observed by EarthCare, not shown here. And then we have this smoke, which ironically is then contributing to cooling of to significant cooling for a few months while these wildfires happen. Okay, I'm moving to the new mission. So we had the launch of how much time? Okay, we had the launches of Sentinels 4 and 5 this summer. Sentinel 4 on the 1st of July. It successfully completed its early phases, reached a geostationary orbit. It's now in decontamination mode, and then the usual steps will follow, including the performance verification of the instrument. For Sentinel 5, we had the launch on 12th of August, and again, it's now in decontamination mode until next week. Then we will have functional performance tests. It's important to note that because these instruments are still in decontamination mode, which is as planned, these are optical instruments, and it's normal to have like 2 to 6 weeks of decontamination at the start of the mission. It means that it's still early days to make any predictions. We can only say so far there are no major hiccups, and things are going well. And we have this rough post-launch schedule, but this will have to be revisited once we know more about the instrument performance. So it's a handover foreseen from ESA to EUMETSAT at about launch plus 12 months, so there will be July or August for the respective missions, and the public data release following that in a staggered way, starting in the second half next year. But I also understand that for the CAMS there will be data releases earlier than that in a staggered way, with issues first and then subsequently cleaner data versions and better data versions. And I think I will hear more from EUMETSAT in a moment on the schedule. Finally, a word on CO2M, the CO2 observing mission, which I show you just here how the hardware is coming together. This is the main instrument, optical bench, and as you heard already earlier today, it is delayed. The first satellite acceptance review is now planned for August 27. The second satellite following half a year later, and then the third satellite in 29. And that was all I had to say. Thank you very much.
Okay. Thanks a lot, Michael. Any burning questions for this? Okay, yeah, here.
For this impressive presentation. Just one addition that in the framework of the EarthCare Plus projects, we are delivering new products for dust. So we have dust separation in the total AOD for the extinction profile, and this is very relevant to air quality policies and the new policy tools of CAMS for assessing the contribution of dust total PM. And this is maybe information for smoke as well that could be used in CAMS.
Thanks. And on the same line, it's also important to mention that I think relatively soon the assimilation of earthquake cloud profiles will start at ECMWF, and I understand then at some point also earthquake aerosol profiles will be used. So this has been prepared over more than a decade because it's very, very novel and very difficult to put that in the model, and we are very happy that this goes relatively fast after launch.
Okay, thank you. I think we will move on now to EUMETSAT. Thanks very much, Michael. And Dominika Leskov-Czeskowska. I pronounced it better earlier today, I can assure you. But she's working on atmospheric composition, user engagement, and will give us an overview of the EUMETSAT operated part of the space segment in Copernicus and other relevant missions and products of relevance to CAMS. The floor is yours.
Thank you, Maria. I know that in the agenda we had two names, me and Stefan. Don't worry, Stefan will come for the panel discussion. So, hello everybody. EUMETSAT. EUMETSAT is the European Organization for Exploitation of Meteorological Satellites. So first thing is exploitation. Here you have a nice picture of our space control room. If you are ever in Darmstadt in our headquarters, come and see for a trip to have a look, quite impressive. And the second part about the name is meteorological. So historically we started from looking at the weather, and we have a long-standing cooperation with ECMWF. If you still remember graph from Richard, I had a look at this one with a number of instruments contributing to IFS. It started in 1996, and from the very beginning we had Meteosat there from EUMETSAT. And now we have 10 operational satellites that we are operating, and it's not only weather anymore, but also environment, ocean, and atmosphere. And our newest babies, launches were already mentioned. There's some pictures, so I'm not going to dwell on that. But in this room, I think it's clear, as Sentinel-5P is, as the name stands, precursor. So Sentinel-4, geostationary, measuring similar every hour over Europe, and Sentinel-5 complementing Sentinel-5P. So we already heard S4 and S5, we have CO2M, and actually we have here also in orange, even though Sentinel-3, which is, even though it stands here monitoring the ocean, but actually we have also some atmospheric data sets, and EUMETSAT is producing near real-time AOD and fire data from that. This mission was not developed for atmospheric applications, and then it turned out actually we can do something about it. So actually, maybe if you're wondering why you hear about Sentinel-3 only recently, well, it took a little bit to get the algorithms mature enough, but now they are really in good shape. And we are contributing to CAMS actually in quite of a number of instruments. Here you have the red ones that they are from EUMETSAT, and the underlined ones that they are the Sentinel-5, 4, and also other instruments on MTGS and EPSSG will provide continuity for those measurements. Again, referring to Richard's presentation, I need to really thank you for this, because you mentioned also this continuity heritage, and we as both operational agencies understand it very well, and therefore we are really planning forward ahead to have this continuity, and also keep in touch how it works and what does not work. So let's have a quick look what we have so far. So starting from fires, we have, I mentioned Sentinel-3 FRP, and now it's actually, I will just highlight that assimilation is CAMS is planned and integration into EFIS, Copernicus Emergency System, is in progress as well. And on the other hand, we have geostationary. If the previous ones were babies, then it's a toddler MTG FCI. We are having 2 products in the demonstrational status. One is from the central facility of EUMETSAT, and the other is from the LANSAF, so Land Surface Analysis Satellite Application Facility. And this produced in European Weather and Cloud. And it's already, even though it's demonstrational, it already proved to be useful for the recent fires. It provides data every 10 minutes, and this is actually a challenge for the CAMS and the assimilation system in general. Yeah, CAMS is really working hard also to figure out how to make the best use of this data. So going quicker, so we have also gone to YASI since 2006. So really, even though maybe lower resolution, but still very relevant for reanalysis and this long-term products. Then we have aerosols from GOMI, from YASI, PMAP, the multi-instrument product. And this is actually the future also for the EPS SG, so METOP SG second generation. We are not looking anymore at one instrument, but actually we're trying to combine this information from the instruments on the platform, as many as possible, to get the best product at the end. And finally, again, Sentinel-3, again, assimilation of AOD is under activation in CAMS. Atmospheric Composition Satellite Application Facility released also since the last General Assembly a few new products. There are from near real time and also climate data records relevant. Have a look at our user portal if you're interested. And Sentinel-5P. So it's undeniably very, very successful mission. And S4 and S5 is building on this heritage. So you all know this number of products that it's delivered in near real time. Then we have some offline products from S5. And finally, we have, I've called it novelty science products from S5. That they will be coming from S5. I know that some of them, for example, Glyoxal is also available from Tropomi, but it was not foreseen at the very beginning of the mission, and it came only later on. But what is actually quite important, here we have also S4. S4 and S5 will come all in our NRT, all those products, including methane, based on carbon dioxide proxy, which we expect to be faster than the full physics retrieval. Then we will have not only S4 and S5, but also YASI and G, and here I highlight specifically ammonia. We have the same spatial resolution, but better spectral resolution, so means higher sensitivity. Also CO for tracking fires, long-range transport. IRS, similarly to YASI, but on the geostationary, providing data every 30 minutes over Europe, and then depending on the site on the geostationary disk, every 3 to 6 hours of the rest of the disk. We have S4, S5, again, on the aerosols, but we also have S3 that we are planning future developments. So, for example, fine mode absorption index, aerosol layer height from Sentinel-3, which means that will be every day with higher resolution than S5P, and aerosol typing, dust, smoke, and ashes. And here we have FreeMI, and this is really completely new instruments, multi-viewing, multi-channel, multi-polarization, which means that finally we will be able to see not only AOD from a satellite, but have some idea about angstrom exponent, SSA, size distribution of the aerosols, aerosol layer height. So this is really data that CAMS is really interested in, because of course EarthCare is again very successful one, but it provides very narrow swath, and 3MI is will be not as precise. There will be some, of course, constraints, but will provide much wider swath. CO2M was already mentioned. We're all waiting for CO2 and methane products, but actually NO2 will be quite a game changer too. Spatial resolution of 2 by 2 kilometers. That's something that you can also already use for some data for urban air quality. Timeline for the new missions availability. Will not dwell onto that. You will have a look later in the presentation. It will take a moment, but we're on track, and there will be additional earlier dissemination for the CalVal users, of course. We are not planning only for NRT, but of course we are having in mind already reprocessing, especially, for example, CO2M, we already know that the reprocessing will be very challenging, so we're already thinking how to cope with that. For the data access, we have the push methods. So UMETcast, so you stand up your own receiving station or antenna, or you just pull, so take data from the UMETSAT data store, Ceph archive. And recently we have Wikio, which is combining data from, you can find also, for example, Sentinel-5P there, and you can have some basic, some computation there as well. We are having this user portal, user.umetsat.int, and we are committed to updating you on time. So for example, the commissioning status on the MTGI you can find already. For the newest ones you will find soon. Keep watching this space. Here are the links for the test data that they are already there. So if you're interested in testing, it's there. That's Laurence already mentioned. We are committed to trainings too. So for example, this year will be already a 7th edition of the joint training. Unfortunately, the registrations are already closed. But if you are having somebody interested maybe with your PhD students, or later on next year, there will be another training. And last year we also had a workshop on wildfires. We want to hear from the community. We want to hear what you need. So please, yeah, for example, on a platform like that, on a forum like that, but also please come to us, reach out to me, to Stefan, to write an email to a help desk. We want to hear from you what you actually want. And as a thank you, I would just leave this slide here. It's the climate symposiums. The registrations are still open until the end of September. If you're interested in discussing how the satellite data can support policies, please come. Thank you.
Thank you, Dominika. And any burning questions? No? Good. All clear? Then we will move on to the last speaker of the session, Carole Daniel, who is managing the atmospheric program for CNES, the French space agency, and she will talk a bit about microcarb and EASI Next Generation, and a bit about their future plans and projects.
Okay, thank you for inviting me for a presentation in front of this assembly. I will give a short presentation of the CNES project and for developing science and application. So in the name of my colleagues at CNES who are dealing with project and also with a lot of input from the French principal scientist of YASI-NG and microcarb scientific mission. Next here, yeah. So there is of course a large Earth observation program at CNES. I will focus only on these two, microcarb and YASI-NG program. And I will start with microcarb. So we launched successfully, as you already heard, on July 25 from Kourou on Vega C. It was a very exciting moment. This mission is developed in cooperation with the UK Space Agency and the European Commission. So it's a scientific mission. It's not an operational mission like the Copernicus mission. And it's firstly dedicated to measure the natural CO2 fluxes at global scale. But we include also a demonstrator mode to try to observe the anthropogenic emission. So as I said, it's a cooperation with the UK Space Agency and European Commission, and also with the strong partnership with EUMETSAT, which will do the operational processing and distribution, especially for the Copernicus users. There will be also another distribution of the data through the French data service distribution IRIS for inside DataTerra infrastructure. So we launched this summer, and we will have a one-year calibration validation process like most of the missions. So what is microcarb CO2 mission? Is a very small instrument. It is one of the innovative aspects of this mission. It's only an 80 kilogram instrument on a microsatellite. It's a passive gratis spectrometer like the OCO2, for example. But we have another innovation. It is the use of a special channel, a 1.27 micron channel, which is polluted, I would say, by air glow phenomena. But we do some research in order to evaluate this pollution and to remove it in order to have a better correction of the CO2 signal from the aerosol, because aerosol is also polluting the CO2 channel. So it's a kind of innovation that we will use for microcarb in order to try to address a better precision. We have a footprint of 4.5 to 9 kilometers square, which is a nominal resolution, with also a specific mode for anthropogenic emission, which will try to downscale this pixel size to 2 by 2 kilometers. There is also an imager on board, and the idea is to measure the CO2 column, integrated column, with a precision better than 1 ppm, and by no bias, I would say, a bias better than 0.2 ppm. We also have the surface-induced fluorescence parameter. So we will, CNES has developed for a complete full physics optimal estimation retrieval, which is called 4-Arctic. And the instrument is placed on the polar sun synchronous orbit. And you can see here the specific modes. We will have the nominal modes above land, which is just under the line of sight of the satellite. We'll have also a scan mirror in order to address different pixels, not only under the track of the satellite, and also a glide mode above the ocean. As I said, we will have the city mode in order to program some more small size pixel above some interesting spot, and also a target mode above a validation site. So where we are right now, we have the first period of 3 weeks of layup, which is early orbit period of the satellite, and then we start the decontamination. We start to cool down the instrument, and also we start the first functional test. And so we will enter the first period of Calval 1, to start to calibrate the spectra, the level 1 of the measurements. around almost February 26, and then we will enter to the next phase, the CalVal 2, which is addressed to validate the level 2, so the concentration of CO2 up to summer next year. And then we will enter the routine mode after that for 4 years. So in the first CalVal 1 period, we will have only data for the expertise at CNES and to the scientists involved in the validation of the spectra. And then we will have some distribution sample to scientists and through the mission advisory group, through IRIS, and then some tests with EUMETSAT, and then a routine where the data will be distributed for Copernicus through EUMETSAT and for scientists through IRIS Data Terra. I have the good surprise yesterday to see that we can show you the first acquisition, which was done Friday last week, above a cloud-free area, above Amazonia. It was confirmed. So you see here the imager scene above Amazonia. It was confirmed, I would say, by Sentinel-2 image. And you can see here the track on right, the track of in green of the footprint of the spectrometer above the city of Foyo in Brazil. And you see down the signal acquired from the spectrometer. So on the 4 band, and the team at CNES already tried to have the first spectra, the level 1B, for the 4 bands of microcarb. So it's very exciting, and I think you are one of the first to see that, and the first presentation at least. And so we are very exciting, and we will do now a better calibration of the spectra in the next weeks, and we are very happy of that. So as I said, the data will be on IRIS, so the French data distribution data portal, with this different specification of level 1, level 2 product, level 3 also for more good, best image with interpolation. The format will be in NetCDF, and then we expect that the scientists will do the fluxes, the level 4. And of course, we expect that Copernicus also will use this data. For that, we have a partnership with EUMETSAT, in preparation of CO2M, will include these activities in the infrastructure. And we expect to have, and we have a partnership so with EUMETSAT through the European Commission to have this processing done operationally by EUMETSAT. So the idea is to have this kind of evolution with a small mission, microcarb, for demonstration of local measurements of CO2, for ecosystemic fluxes. And then after, the idea is to have a bigger instrument from ESA, the CO2M mission, to add at the end with a complete European system for CO2 fluxes. On the other hand, we know that there is the US with OCO2 and OCO3, which probably stopped the operation, unfortunately, even if it works, still work. We also have the Japanese colleagues, which procures the GOSAT-1, GOSAT-2 data. And you know that end of June, there was the GOSAT-3 or GOSAT-GW with a new instrument. So we are very excited also to use this data for CO2. And there is many discussion also with Chinese colleagues who had a lot of instruments in space, but unfortunately the data are more difficult to get. But we discussed in Europe a lot with them, and we hope that the collaboration will be at least will have some will be fruitful. I will say also a few words about YASI-NG. We successfully launched this instrument on board the METOP SG-A1 this summer, as you know, and we say that before. Here you have the two principal scientists in France, Cathy Clairbeau and Cyril Crévoisier, which were on site in Kourou for the launch. Why I will talk about YASI-NG, because CNES had started with EUMETSAT a collaboration a long time ago with YASI, where EUMETSAT delegated to YASI the building of the instrument, the definition and the building of the instrument, and also the development of the operational processing chain So we have a big part in these instruments, and also with YASI and with YASI new generation, which will be the same in continuity of YASI, with the same pixel size of 12 kilometers diameter, but with radiometric noise and a spectral resolution better by a factor 2. So we expect to have many more results for atmospheric composition. Of course, you know that YASI and YASI new generation are for several communities. First of all, the new numerical weather prediction with temperature and water vapor measurements, but also for atmospheric composition and climate, and it was confirmed year by year with the result of YASI. We had with this, YASI works in the thermal infrared domain, so in complete complementarity with the Sentinel, which work in the UVVs spectra. And we think that it's very important to have this synergy between the infrared observation and the UV, even for the atmospheric composition and climate. So here is a slide from the LATMOS showing that we have a lot of results in different items using the YASI and tomorrow the YASI new generation observation for atmospheric profiling, for measuring the essential climate variable, clouds, greenhouse gas, aerosols, to improve the pollution forecast, to better tracking long-range pollution. So we have a lot of benefit of the YASI and for atmospheric composition. Here you have already the use, we see that before, but it's another way to show it, the product of YASI used in the Copernicus service, even if it's not a Sentinel. So in CAMS, the CO2 and CH4 is assimilated in near real time. It's a product from the LMD in France. We also have the product of CO and SO2, which is assimilated. We have for future assimilation ozone and ammonia, also from the Belgium and French laboratory product for Lee. And for also in the climate service, we have some product from YASI, the CO2, the CH4, the ozone, and the dust. And there is also some use of the YASI product in the ESA CCI project. So what is the next step for YASI new generation, which was launched August 12? So we have also the early period phase of 3 days, which is okay. Up to the mid-November, we will have the decontamination, the mechanism declamped and detector cool down, and the first health check. So we wait for that. And unfortunately, I don't have any signal to show you for this mission, for this instrument. So the idea also is to have 16 weeks of CalVal part 1 in order to have a technical evaluation and early validation of level 1 product at CNES. And then a second period of CalVal 2 up to summer 26 to have a CalVal part 2, part B for YASI-NG, dedicated to sounder spectral calibration, geometry intercalibration, and quality check for the EUMETSAT processing. So I would say again that YASI is a key and historic contributor to Copernicus services, demonstrating that near real-time processing, data delivery, and operation activity now go far beyond just classical numerical weather prediction activities, that we have a strong implication of level 1 and level 2 monitoring and validation in the French laboratories with support of CNES. And we hope a lot for the YASI new generation, thanks to the new performance of the instrument. It's important also to recall that we want to keep the stability between YASI and YASI new generation, also for climate studies, because we keep a lot of parameters similar between YASI and YASI new generation in order to keep the stability in the spectra and have a very long-term data processing starting from 2006. Of course, we will have the synergy with Sentinel-5, Sentinel-4, and 3MI, which is also very expected for new product. So thank you for your attention.
Thank you, Carol. Any burning and quick questions? No, good. Let's, okay, Carol, you can, because then we can still have a short panel discussion. So please take a seat. I think I will have this one, and you can. And then, as foreseen, we have a little costume change from EUMETSAT side. So here we have Stefan Bosinski, who also works with user preparation and user uptake from EUMETSAT. I think I will kick off this discussion, and then we will take some questions from the audience. But first, now we have heard a bit about your plans, but looking a bit further into the future, let's say 20 years or so, how does the Earth observation scene look? How does it develop? What are the main priorities and also potential challenges? Who wants to take the floor on this? Yes. EUMETSAT, please.
Is this working? Yeah.
Yes.
Okay. Hello, I'm Stefan Brzezinski, EUMETSAT. It's a tough question. I'm involved in an effort at the level of World Meteorological Organization, which is called Developing a Vision for 2050. So it's a technology foresight effort, together with many space agencies around the world, to try to anticipate what the observing system should look like in 2050 to meet the needs of users across weather, climate, hydrology, etc. And there is a conviction around the drafting team, and also many users and people from the AI/ML world are there, that says we definitely need a backbone system. We need a backbone, a baseline, a constellation of satellites that provides continuity and that provides also a reference that is quality controlled, that is well calibrated and validated in terms of the geophysical information it provides, the radiances it provides. And in addition to this backbone or baseline, whatever word you prefer, there can be many, many other contributions from constellations of satellites in various orbits, from private actors, and there are many of them who are more or less successful. We'll have to see how sustainable the business models are, but there will be contributions from such actors in Earth observation, which will complement and fill gaps where the baseline backbone missions do not provide data. And that is sort of the very high level, I would say, consensus. So if you ask me what do I anticipate, I think there needs to be a strong baseline backbone operational constellation. There needs to be a strong R&D component. We've heard a lot about this here. We need stable and consistent reference measurements on the ground to be able to calibrate and validate what we see from space. And we need, of course, the data, which is something you are all interested in. So we need reliable services and data services that are user-friendly. And I think just one more point. Those of you who are not in the satellite world, this may have sounded very scattered and a bit confusing. I think overall, the space agencies, it works quite well overall in serving our users. And we can always do better. And there are many products coming, and we should put pressure on ourselves to make the life of users easy by multi-sensor products, merge products, easy data access, and good user documentation and training.
Okay, thanks for that reply. That was clear speech. Yeah, you want to take the floor?
Yeah, from the ESA perspective, I mean, we're not going to 2050. We have ESA strategy 2040, and there's 5 overarching goals. And the very first one is protecting the planet and its climate. It's number one, and another important one in that context is also European autonomy, and that of course is mostly directed at the launchers, but I think it's also relevant for the Earth observations, the way the world is developing. So, but we are, I think, currently very well positioned for that with a world-leading Earth observation system in Europe, thanks to the cooperation between the three big partners, EUMETSAT, the Commission, and ESA, and the Commission in particular, and EUMETSAT give us the long-term continuity. We have currently, I checked it, 23 new missions in the pipeline, as we call it, until 2040, of which 13 are Sentinels. So that and follow-ons. So that's really impressive, and also shows in a way that the scene is already quite set in the way things are planned, because the meteorological and the Sentinel missions are long-term missions, long-term services. And then on top of that, we have the research missions, which come like every 3 years on average, and which are not random, but which are basically selected out of a pool of scientific ideas, and of course our science strategy, and that's also a new one. So last year the Earth Observation Science Strategy was published, and I invite you to have a look. That gives like the boundary conditions for that, and we were very lucky this year with the Earth Explorer 11 selection that there were 2 atmospheric missions, and we selected one of them, which is a little bit more on the meteorological side, so not so good news for the composition community. And then we have the scouts, which bring the flexibility, and I think that's one of the challenges, that it's a bit like a super tanker, and all these missions take enormously long to prepare and are enormously complex, and we always have delays, and it's just fact. And then the reality, as I mentioned, is changing so fast that we might have to improvise a bit and bring these extra missions in between to react to new developments. Yeah. But I think we already have a very good baseline of what we can observe. I mean, the electromagnetic spectrum is limited. It's only so much we can see, and we're covering a large part of it. We are now pushing a little bit the boundaries into the very far infrared with forum, and into the like terahertz with very advanced microwave technology. But I mean, then we are covering a spectrum. That's what we can do.
All right, thanks. Yeah, Carol?
Yeah, just for me to simplify, I think there is 2 game changers in the last years. First, Copernicus. I think the Copernicus really changed the point of view. I think that the space agency like CNES think about the new mission, because now it's not only techno-push, it's not only technology which propose some solution for scientists, it's also now the user point of view, which is taken from the beginning. And I think it changed a lot, even for science, even for the science community, which is also very in synergy with the operational community for Earth observation. So it is the first game changer, clearly. And the second one is also the private sector, which comes more and more for Earth observation and Earth application, environmental services, and so on. And all these 2, I think, give us some more thinking about more resolution, because we want to address what is going on the ground for the society and in answering the regulation issues. So I think that even for research and development agencies like CNES, we think about more in terms of user needs. First of all, user, not only scientists, but user for all the society. And also in terms of more answering the question of regulation issues for environmental aspect. with more resolution. For example, we are thinking about the next infrared sounder for the next generation in the continuity of the YASI new generation with a much more smaller pixel size, because it is what we would like to address now. So we need to develop some technology for that, of course. But again, I think that would be my answer to your question.
Great, thank you. Richard, please.
No, yeah, no, it was. Thank you, Carol, for this link, making this link, because that's exactly where I wanted to go to as well. I'm here sitting in sort of the user role, which is different from being a data provider to other users. But atmospheric composition, we talk about a world that's not very well observed in the end. I mean, we have beautiful satellite missions, and many of them, but they're all focused on maybe 8, 9 of the key species and things we have in the atmosphere that we want to look at. The rest, at the moment, we fill in with our modeling capacities. So the more we can observe, the better. Of course, we are limited by the physics of the whole remote sensing problem. We cannot do everything we want. But for me, it's key to keep pushing the technology, the science, to see what we can get out of remote sensing. And I know it's already happening. We see great developments. There was 3MI was mentioned, which is really next step up for aerosol observations. But for aerosols right now, we work with a measurement that gives us the total column of all the aerosols in the air. We don't know what altitude, we don't know what species. So making these improvements is going to be really important. So if we can get that out of the future generation of satellite sensors, I think that's key. Then for us, a challenge will be what you said as well, is the combination of the sort of traditional satellites we get from the space agencies, and then this whole rapid developing commercial sector. And it's exciting because there's lots of innovative ideas, and because these satellites tend to be very small, they're cheaper, so there's a lot happening. But then in the end, dealing with them in an operational system is going to be not the easiest. But we need to think about is how we do this, and then I agree with what Stefan was saying. We need probably kind of a benchmark system of publicly funded satellites that are long-term planned, coordinated across the globe, and then bring in all these exciting small missions.
Yeah, thank you. Thanks for those inputs. Okay, I think we will open the floor to the audience for at least one question, if there are any. Yeah, over here. Can we have a microphone is coming?
Yeah, I would like to maybe come back to what Richard was saying. Satellites have a lot of advantages. They provide a global view. In terms of management, you look at the whole planet, you get a column. But it also has some limits, which were mentioned, for example, the vertical distribution of the species. And so if we look at the history of the meteorology community, they started without having satellites, and they needed to have a global view of the weather, which they got through a collaboration through WMO, I think in particular, of all the meteorological service working together. And then the satellite came, and all that was integrated in a single system that helps then doing global and regional weather forecast. So isn't it a very, very important issue to try to integrate surface measurements, aircraft measurements, all kind of measurements you have with satellite observation in an operational way? In other words, don't we need to create a worldwide system to bring together the data from the Europeans, the Americans, the Chinese, the Indian, the Africans, into a single framework that complement what the satellites are doing, and then having, of course, the capability of assimilating all that in one single system, operationally?
Okay, wow. Anyone wants to come in on this? Yeah? Stefan? worldwide system?
Thank you, Guy. I remember your days from the World Climate Research Program and MPI Hamburg and so on. So thanks for a great question. In a sense, it's already there. Because if you look at Richard's slide on how many data from how many satellite missions ECMWF use in their IFS, that's not just ECMWF doing this, it's many global centers around the world doing this. And of course, they integrate aircraft data, they integrate surface data from many sources that is exchanged under WMO exchange rules and the information system that WMO provides. So in a sense, this accessibility of the entirety of data and the integration into an application like NWP is already there, has been there for many years. I would go further and say, do we need something like a huge database where a machine learning algorithm can very quickly run through the entire global observing system data set for any particular day and do correlation analysis or do training on a forecast? I mean, that's something that isn't there as far as I can tell, and I don't think the data providers are in a position to do that because each one of them has their own data policies and data exchange rules and data exchange mechanisms. But at the WMO level, it's something that's being thought about in the framework of what's called the WMO Integrated Global Observing System.
Okay, thanks. We're running a bit short on time, but I would like if we have one more reply. A short one, yeah?
I guess I'm not entirely sure what you mean by one global integrated system. As Stefan said, there's different centers running similar systems. So it's not just one system. We try to collaborate. And as an example, maybe which is on the latest developments in terms of greenhouse gas emission monitoring and greenhouse gas monitoring in itself. Within WMO, we are trying to set up this global greenhouse gas watch as a framework of global coordination. So here we work together with the Americans, with the Japanese, with the Chinese to see how do we set up a coordinated monitoring system of systems, or whatever you want to call it, that makes use of all the satellite data, which are coordinated through CEOS, for instance, where the space agencies do work together and where they also reach out now to the commercial sector. So bring that together with the WMO expertise on promoting and managing in situ networks around the globe. Of course, it all needs funding in the end, so there's lots of uncertainties, but at least we're trying to see how we can coordinate this well. But the decision was taken, we need more than one system at this stage. We just want to make sure we have different ways of doing this and can compare those. And one might be a little bit more ahead than the other, but allows the other to catch up and try to see how we can move forward as a global community.
Okay, thank you.
Just to say that I think Europe did it first with Copernicus. I think it's a kind of model that can inspire the other step. We maybe at international level, let's say that. But I think we can be very proud that already in Europe, the member states try to integrate all that, and it works. So,
yeah. Great. So on that
congratulations.
note, we will thank you to all of the panelists and presentations, and we will break for a coffee break, and then we will have the photo first now. Or?
Yes.
Okay.
Thank you. Thank you, Maya. Yes. Thank you very much. We will have a group photo now, so please stay in the room. It will take only a few minutes. And once again, many thanks for this panel discussion and your presentation. Many thanks to all of you. Yeah, thank you.
So, good afternoon. We're going to start a session now on research development projects as supporting CAMS, and we're going to have a number of speakers. Each of them will talk 10 minutes, so I'm going to be a bit strict on the timing because I always want everybody to be at dinner on time. And so we're going to start with Natasha Antoniou, who is online, I think. And yeah, I can see her. Can you hear us? It seems so.
Yes,
right?
yes. I
But
can
we
hear
don't
you
hear
very
you.
well.
We don't
I can hear you.
Yes, now we hear you. Good. So you're going to talk a little bit, giving an introduction about, I think, health-related issue. So why don't you start? 10 minutes.
Yes. Yes, thank you so much. So let me put also my timer. Actually, I'm not going to talk about health issues, but I know that the title is a bit confusing. That's why I'm here to explain everything. So first of all, good afternoon, ladies and gentlemen. I hope you can hear me loud and clear, which is the case. My name is Natasha Antoniou, and I work as a project advisor in the Space Research Unit at HADEA. And I would have loved to be with you in Prague today, but unfortunately, due to other commitments, I'm joining you only online. But I'm sure the event has been productive, and I've been following the sessions online from this morning and before, and actually all the discussions are very interesting. So I'm pleased to open the session on CAMS supporting R&D projects. And the goal of my presentation is to provide you an overview of HADEA and our research project linked to CAMS. And then I will give the floor to our project representatives who will share more details about their activities, objectives, and achievements so far. So let's start. I'm pretty sure, and I mean, there was already the confusion about the topic. I'm pretty sure that not all of you are familiar with HADEA. So HADEA is the European Health and Digital Executive Agency, and as it's stated stating in the title, as an executive agency, we implement European programs and initiatives on behalf of the European Commission. We manage a wide range of projects across health, digital, food, and industry. But I'm here today to present because we have a very important portfolio of EU space research projects. And how we work very closely with what we call parent DGs. For example, for our space research unit, our parent DG is DigiDefis. There are some colleagues from DigiDefis there with you. To help you understand the different roles, our policy colleagues from the different DGs formulate policies, and what we do, we transform those policies into actions. This means that we organize calls for proposals, and we ensure that the best research proposals are selected. And this is very important. Once they're selected, we make sure that these projects are successfully implemented, and we close the loop communicating their outcomes back to our colleagues in the parent DGs. In our case, we're working very closely with the colleagues from DigiDefis. We are always inviting them to the review meetings of the project. We exchange, so we have a very close collaboration. Now, a few words about our space research unit. It's divided into two sectors, the space technology and the space services. I'm working in space services. And in this sector, what is interesting for you, you see there we have different portfolios. What is interesting for you is the Copernicus Service Evolution portfolio and the related projects. And these projects are actually funded under Horizon Europe Framework Program. And as you know, it has been built on the strong legacy of Horizon 2020. With this slide, don't be scared. I won't go through all the details, but it's important for you to know that the space research calls are part of the cluster 4, which is the digital industry in space and falls under pillar 2. So now, what is the general context of the Copernicus Service Evolution projects? The first bullet point is what I mentioned previously related to Horizon Europe. I will focus on the second one, which means that the project of the Copernicus Service Evolution focus on tier 3, research and innovation. So what we are targeting, we're targeting projects with medium to long-term advances rather than having short-term operational upgrades. Also, as you all know, Copernicus is a user-driven program. So, and you know, the goal is always to continuously adapt to the user needs and understand the policy challenges, and together with the latest scientific and technological development to work together. And the session this morning, for the users' requirements, it's a great example. So we always have to work with the user to understand what they need. Last but not least, there are the short and long-term R&D priorities for future evolution. as it's outlined in the Earth Observation Strategic Research and Innovation Agenda. And for those who haven't read this document, I actually encourage you to do it because it's very interesting and gives you all the details. So moving to the cross-cutting elements and the expectations we have from the projects, I'm starting with, and I'm emphasizing always that what we're looking for, we're looking of research results which can move to operation. In other words, we want to have tangible results. We want to have new or improved products or services that can be used from the Copernicus services. We also encourage a lot strong collaboration, interaction with the relevant and trusted entities to make sure that they use the results. In the case of CAMS, that's obviously the case because ECMWF is coordinating several of our projects, and if they're not coordinating, they're part of the consortium, part of the advisory board, so the collaboration is there and the exchange is there, but that's not always the case with other entrusted entities. Last but not least, the synergies between ESA activities is fundamental. In the previous session, we saw a colleague from ESA present all these nice portfolio they have. So we always want the project to know what's happening there, to discuss with ESA, and I've put also the group on Earth observation and the EuroGeo initiative because that's another European initiative, and actually in middle of October, they have their workshop in The Hague, in the Netherlands, where we have already put the relevant project in contact with them to go and present their results and start the discussion. Now, moving to the next slide, I think this is our favorite one because at HADE we're proud of our diverse Copernicus Service Evolution projects. There are two main lines of activities under CAMS, as you will see, with 4 ongoing projects that they will present after me. And but we also support projects linked to the other services. So we have the climate change, marine, land, security, and emergency. Additionally, on the bottom, you will see the cross-cutting project that support multiple services. But not only these projects support multiple services. Other projects, whenever is possible, should seek, and actually they are seeking synergies among the different services. On the top of the image, you will see that there are different phases. The gray one is the Horizon 2020, where you will see a very long list of projects, and you know already the seeds and Cocoa 2. But then we are moving to the blue era, which is the Horizon Europe. The first call was in 2021, and we had several projects. Afterwards, there was a call in 2023, where there have been 5 new projects. And in last year, we had another call. We had 4 more projects, but not anything related to CAMS. But actually, currently, there's the 2025 call open, and very soon we'll start evaluation. So my team and I were very busy preparing everything. We're expecting 6 new projects in total for the Copernicus Service Evolution. But again, I'll give you more details in the next slide. So now moving and zooming actually to our current 4 and relevant projects for you. But again, I will leave the details to the project representatives. There are 2 main lines of activities under CAMS. The first one, the upper 2 projects focus on atmospheric pollutant and air quality, while the bottom line projects support the preparation of the CO2 MVS. For the sake of time, I won't mention the project in gray because I assume by now you already know them very well because the current projects have been built on their results. So quickly, because we don't have so much time, Cameo is an ongoing project coordinated by ECMWF, focusing on improving data assimilation methods and developing enhanced certain information and for selected products, while Camera, the newer addition, but not so new anymore, focuses actually on aerosol and precursor gases, working to improve regional and also global aerosol modeling capacities. And this one is coordinated by Hageos. Now, moving to Corso and Corso and Katrine. Corso Katrine contribute significantly to the CO2 MVS capacity, and especially now with the recent successful launches of the 2 Copernicus Sentinel satellites during the summer. We have the Corso, which focuses on better use of the co-emitted species and auxiliary observation to improve the estimation of anthropogenic CO2, while with Katrine, the most recent project, is working on the evaluation and the improvement of the numerical scheme for tracer transport. Both projects are coordinated by ECMWF. Of course, I would like to mention here that for the sake of space, I've mentioned only the project coordinators, but obviously behind each project, it's always a strong consortium of dedicated partners working very hard to deliver what they have promised, and the credit should go to all of them. So I know for all of these projects, there are several partners in the room, so the credit should go to all of them. And now moving forward, because work doesn't stop. As I mentioned earlier, the EU Space Call 2025 is open, and the deadline actually is approaching. It's on the 25th of September. And here you can see the six projects, the 6 topics that I've mentioned previously. For CAMS, we have 2 topics, the 42, which is the CAMS evolution, and we have the 43, which is the CO2 MVS capacity. In each topic, we're expecting 1 project to be funded with a budget of 3 million euros each. What we always do, we are always looking for experts to evaluate our proposals and monitor our funded project. And events like yours is the best place to recruit new experts. So if you're interested and you don't have any conflict of interest, because this is fundamental, you can scan this QR code or you can contact me directly. And closing, I would like to mention the booster, because it's a great initiative of the European Commission. It's a great tool and not so many people are aware of it. The booster is actually free of charge. What they're trying to do with the booster is trying to strengthen the dissemination exploitation strategies and eventually help the projects to go to market. Again, this morning, we heard for different products that they have been operational. So, of course, our projects are in research and innovation, but nevertheless, we always want to put emphasis. And when there's something very good, then there are these mechanisms that they can support them to go to the market. There is actually 1 session coming up on 24th of September. It lasts only 1 hour. So in case someone of you is interested, feel free to look online or again, take a picture of this QR code and follow it. So last but not least, a bit of promotion material to please my colleagues, the communication from the communication team. We are working very hard in the end of, when many projects are finishing together, we are working and we are developing this Cordix results pack, where you will see all the projects which have been finished. And this one is very interesting, it's very nice. You can go and check it online. Over there, you can see the COCO 2. And then when the new project will finish, most probably we'll do a similar exercise, because it's always very good to have an overview of the project and what they have been doing and how they have been contributing in general. So if you want to know more about HADEA, our agency, and our projects, you can always visit our website, but also feel free to follow us on social media. Again, my colleagues will be very happy. And particularly, you can follow our LinkedIn account. We are very active and we're promoting extensively our space-related activities and our projects. So I'm perfectly on time. Thank you so much for the attention. And I would like now to hand over to our project representatives who will give you further insights and more details. Thank you.
Okay. Thank you very much for this excellent presentation, which really puts the whole afternoon, at least this session, into a very broad context. So thank you very much. Let's see if there is 1 or 2 quick questions. We will come back, of course, to the individual project later on, but they might be from the broader agency perspective. A question from one of you? I don't see anybody, so that means that it was very clear for everybody, which is good. So we're going to go on now with the 4 projects that start with a C, all of them. Corso first, and I'm going to ask Hauke Visser from ECMWF to give a 10-minute presentation.
Yes, Thank you very much, Guy. So I will be presenting to you an overview of the Corso project, which runs for 3 years and it's about to finish at the end of this year. Corso stands for CO2 MVS Research on Supplementary Observations, and I will explain what it's all about in the coming slides. The overview of the project, so the objective is to contribute to the CO2 Monitoring and Verification Service, or the CO2 MVS that you've already heard about earlier today. The consortium consists of 16 partners, and ECMWF is the coordinating organization. You see the consortium partners listed on this slide, covering various countries in Europe, of course. So indeed, it's contributing to the greenhouse gas emission monitoring capacity that is under development right now. And this is meant to provide all sorts of data to a wide range of actors, stakeholders in society, which you see on the right part of the slide. And it's mainly in support of climate agreements at global scales, but also at smaller scales. But if we look a bit under the hood, we see that there is an integration and modeling step. So this is more the left part of the slide, where we use modeling and data assimilation systems to ingest prior information, what we already know about the magnitude and the spatial distribution and the timing of the emissions, together with observations of atmospheric CO2 and methane, to come together and deliver emission information that is then based on these two components, these two input components. There is a fundamental challenge related to monitoring anthropogenic emissions, namely that you cannot directly measure anthropogenic emissions themselves. So the only thing that you can measure is the total column concentration with a satellite, then at least, of course. This is a forward model simulation done with the IFS, but this is more or less also the type of data that a satellite would provide. Of course, you see that currently, so this is at the end of winter, more or less, start of spring, and it means that the concentrations are highest in the northern hemisphere and lower in the southern hemisphere, so there's a seasonality there. And you see the circulation patterns transporting the CO2 across the globe, but you cannot really tell based on this where the anthropogenic CO2 is actually emitted. And this is the challenge. So this is due to the high atmospheric lifetime of CO2. So when it's emitted, it's immediately transported away from the source and stays in the atmosphere. And also, besides anthropogenic emissions, there's also various other processes contributing to the CO2 mixing ratios. So in Corso, we try to address this by using supplementary observations. So that's the main important thing. So here we use air pollutants, tracers of the carbon cycle, and also satellite observations of the land surface or the natural biosphere. And this is then combined with also improvements in our prior information of the emissions, together with improvements in the data assimilation system, so that we can actually make use of all these supplementary observations. So a broad overview of what each work package contributes. There are 4 in total that are really doing the science, and then there's a coordination dissemination work package. So work package 1 focuses on improving this prior information of the emission factors and also the emission ratios between CO2 and co-emitted air pollutants, so that we can actually later on use these co-emitted air pollutants to put constraints on CO2 emissions as well. So work package 1 focuses more on the bottom-up information, but work package 2 is kind of the top-down counterpart of that, and they're trying to develop data assimilations further so that we can actually use the observations of NO2 and carbon monoxide, which are co-emitted with CO2, to better estimate the anthropogenic CO2 emission component. Work package 3 then focuses on carbon cycle tracers, which can also help isolate the anthropogenic signal from observed CO2 variability. And in work package 4, there's a team working on developing coupled land-atmosphere data assimilation systems by using more satellite observations of the land surface, for example, soil moisture, solar-induced fluorescence, etc. And the cross-working package aim is to provide very specific recommendations for the operational implementation of all these components. That was already highlighted by Natasha as a very important overarching goal of all these projects, and Richard will actually also go into more detail later. So now I will briefly go through all of these work packages, and I will try to give you a nice overview, but I cannot be comprehensive. This is due to time constraints, because there's actually a lot of work being done in these projects. So work package 1 focuses, like I said, on the improved bottom-up emissions of CO2 and also those co-emitted species. So there is a team working, for example, on point source emissions, which are a very large contributor to total anthropogenic emissions. And they are compiling a database of these point sources emissions for CO2, but also for the co-emitted species. Then on the bottom left, what you see is that these emissions are also validated by other teams in this project based on remote sensing observations. And on the right side, you see, top right, you see work presented by a team that is working on an ensemble-based data set of fossil fuel CO2 emissions. And this is very nice because with this we can actually get better uncertainty estimates of these CO2 emissions, which is a good, very important input to the data assimilation systems. And the same thing is then done on the bottom right for the emission ratios between CO2 and the co-emitted species. And all this data, like I said, is actually input to the second work package, which focuses on the development, but more from the data assimilation side. So here, teams are working on emission estimates directly from remote sensing observations. So they use individual scans from satellites like Tropomi, detect plumes there, and then try to estimate the emissions. So there's examples here for CO and for NO2. Then there's also work on speeding up or making the NOx chemistry algorithms more efficient by using machine learning approaches. Because if you want to run a very complicated chemistry scheme alongside the CO2 emission inversion, this is computationally not feasible. So this is why we're looking into machine learning techniques. And then on the bottom, this is really the development of this joint CO2, CO, NOx inversion system, which will then ultimately be the end goal of this work package. And with some preliminary work, and that is what you see on the bottom right, we are actually able to already provide some estimates of CO2 emissions. And the end goal is actually to assimilate those data-driven emission estimates from the top left into the global system as well, so that we're really working across the different scales. So work package 3 focuses on the carbon cycle tracers. So those are radiocarbon in CO2 and atmospheric potential oxygen. And these are tracers that can actually help isolate the fossil fuel signal from CO2 observations. So this has a very strong observational component because the team has been working on an intensive observation campaign in Europe for these species. And they've also been compiling data from elsewhere in the world into one single observational database. And these data are then used in other inverse modeling systems by project partners to provide constraints on CO2 emissions. And that's what you see on the bottom of this slide. Lastly, there is work on novel use of satellite observations of the natural biosphere. In this particular example, I show a simulation of solar-induced fluorescence in the IFS, so by colleagues at ECMWF, where they actually show that the effect of SIF data assimilation on the model's leaf area index. And especially in croplands, you see improvements in the leaf area index, which is then simulated by EC Land, which is our land model. And these areas are particularly in croplands, highlighted by the blue areas that you see on the slide. And so in this way, Corso paves the way for the future land surface observations assimilation as part of the CO2 MVS, but also the numerical weather prediction. And this is all I have time for, I think, so I will stop here and take some questions if there are any.
Questions? You did a perfect job. Everybody understood. Good. Thank you. Let's now move to the Cameo project, and Flora Kluge is going to give us the presentation.
That's better. Hello, everyone. My name is Flora Kluge. I work at ECMWF on the CAMS evolution project Cameo. Sorry, here's the pointer. Yes. Cameo is a Horizon Europe project that consists of 22 partners from all over Europe. It started in the beginning of 2023 and is now in its end phase. Generally, Cameo focused on two central topics. One are uncertainty estimates for a variety of different CAMS products. And the second main topic is the long-term development and improvement of the CAMS data assimilation system, both for the global and also for the regional models. The project started 3 years ago, which means that it's now about to finish and lots of results have been produced. I only have time to show very few of them, but there is a project webpage, of course, with lots of additional information, and you're welcome to have a look there. In more detail, Cameo focused on 3 topics. First, the preparation of the CAMS system for new types of satellite data and preparation for upcoming Copernicus missions, with a particular focus on the new geostationary satellites. Second main topic was the improvement of the data assimilation system. Here, the work focused on 2 main groups of CAMS products, one being aerosols, for which a new radiance assimilation system was developed for the global model, and new satellite retrievals and ground-based observations were used for the assimilation in the regional models. Second main group of CAMS products here were reactive trace gases, in particular trace gases emitted by vegetation, for which new assimilation systems were developed, and one final goal was the development of an observation-based constraint of biogenic emissions for the global model. The third main topic of the project were uncertainty estimates. The work in this part of the project required the development of new methodologies to derive uncertainties and to quantify them for a variety of products, to provide them to the community and to potentially also use them to improve the products. All efforts done in the project are meant to be evaluated and potentially included into the CAMS system. Starting with the first work package of 6, this work package focused all on the improved assimilation of aerosols in the CAMS system. The work involved different aspects of aerosol assimilation, from the harmonization of different aerosol retrievals to the development of new aerosol products from the retrievals. But one particular highlight of this work package was the work towards the direct assimilation of aerosols in the global CAMS system, in contrast to the already implemented assimilation of aerosol products. And how this can potentially improve our CAMS aerosol information is shown on the right side, where we see in the upper left visible radiances based on observations on the left and based on IFS compo simulations on the right side. And those simulations were performed based on the current radiative transfer solver, which uses cloud information and does not contain aerosol information. And the lack of aerosol information in this case causes IFS compo to completely miss a large dust storm event west of the African coast. So one scope of the Cameo project was to develop an assimilation system that uses aerosol-affected visible radiances, hoping to capture such events in the future. So far, in the past 3 years, the system has been developed and implemented and tested, and most recent tests already include observations of reflectance from the MODIS satellite instrument, as shown in the lower right. The second work package put large efforts into the preparation of the global CAMS system for upcoming Copernicus missions, with particular focus on geostationary data from GEMS, Tempo, and then potentially soon also from Sentinel-4. Since this new geostationary satellite data has the potential to improve our data assimilation due to the additional information from inter-daily data delivery. Second aspect of this work package was the work on the development of an observation-based emission inversion system for biogenic emissions for the global model. This work involved the development of an assimilation system for formaldehyde, which required first a significantly simplified atmospheric chemistry system. So far, this simplified chemistry was successfully developed, and the assimilation system included, and most recent analysis already shows the assimilation of geostationary formaldehyde retrievals as shown in the lower right plot. Final aspect of this work package was the improvement of the data assimilation of long-lived trace gases by accounting for uncertainties in the model and dynamical constraints. This work was particularly successful in the sense that it not only improved our CAMS analysis, but also NWP forecast scores for relative humidity and temperature. Similar work was also done for the ensemble of regional CAMS models. Large efforts were gone into the preparation of the models for the upcoming Sentinel-4 data, but also lots of work has gone into the improvement of aerosol assimilation by making use of more satellite data, and in particular also ground-based observations from a large LiDAR network in Europe. One particular highlight of this work package was the assimilation of tropomi observations, for example, of sulfur dioxide, as shown exemplarily on your right side, where we see how this assimilation improves sulfur dioxide of one of the regional models over one of the emission hotspots, the Etna volcano. Coming to the second half of the project, now it's all about uncertainties. We start with uncertainty estimates for the CAMS radiation service CRS. CRS provides solar radiation estimates, which are of particular interest to the solar energy community. And thanks to the efforts in the CAMEO project, we now have uncertainties for those radiation estimates, which are provided both as map-like inventories, but also as a function of time, as shown on the right side. Those uncertainties were derived based on a purely data-driven approach, and it's the first time that we have such information at all. I will not go into more detail here because I know there's a dedicated session tomorrow morning about this topic, so I will leave it to that. Work package 5 focused on uncertainty estimates for emission inventories and surface fluxes. Such inventories are of particular importance for the CAMS system because both the CAMS inverse modeling and CAMS CO2, methane, NO2 emission inversion products, they all rely on data sets that describe the underlying emissions, which makes those data sets very important and their uncertainty equally interesting. It is, however, difficult to quantify because usually no corresponding observations exist. In CAMEO, in work package 5, uncertainty estimates were derived for our emission inventories based on independent inversion systems and emission observation constraints. One example is shown on the right side for biogenic emissions that we use in the global system, for which uncertainties were derived based on key input parameters like leaf area index and emission factors. Finally, the last work package focused on uncertainty estimates for regional CAMS policy products and the global forecasts. For the global forecasts, uncertainty were derived based on an ensemble-driven approach following the example of the NWP ensemble, which means that experimental ensemble was developed for IFS Compo and then used to better understand how different input parameters all combine to the total uncertainty of the forecast, and in particular also how their contribution evolves with forecast time. One example is shown on the right side, where we see the forecast of a dust storm event over Europe, and in the lower two plots, how different input parameters like initial conditions and meteorology contribute to the total uncertainty of this forecast as a function of the forecast time. So this is really valuable information, because if we better understand how the uncertainty is composed at a given time, we can potentially improve the forecast, but in particular also give better constraints on how confident the forecast is at a given time. This was the last of my Cameo highlights. One last slide, I would like to point out that there are 2 upcoming workshops in October where results, in particular from the uncertainty estimates, are going to be presented. Yes, thank you.
Any question? Don't go away too quickly.
Yes.
Go ahead.
Yeah, thank you. Maybe I missed it, but you didn't say much about 3MI, I think. So what's the state of plan work regarding preparing for... It was there? So what are the, say, provisions you've put in place to prepare for 3MI? Like, have you used the test data that was made available by EUMETSAT? And then what kind of parameters were you actually interested in? Because there are several.
Yes, I think that's a detailed question that I'm not the best one to answer. I don't know if Antje Innes knows more about this. Otherwise, I would propose to ask the work package leaders who are busy with this work.
There is some work in work package 1 regarding 3MI to look at harmonizing retrievals and also looking at the importance of using CAMS products in the a priori, for example. But I think work on 3MI is more done in the CAMERA project, where they look at aerosols. And I know a colleague of mine is definitely looking at 3MI test data, but that's not part of the Cameo work.
One more question. It's a comment, a response.
It's a response just to add to Andrew that we did look at this EUMETSAT derived data set and compare it to model data, actually. So we did process the data, and that was done actually partly on your side by Sorhela, etc. So yeah, that's it's been used.
Good. Thank you very much. Let's move now to the Catherine project, and it's Adrien Martinez who will give the talk, please.
Hello everyone, so I'm Adrien Martinez, I will give you some highlight on Catherine project. So Catherine standing for Carbon Atmospheric Tracer Research to improve numerics and evaluation. The project has been running for now 1 year and a half over its 3-year duration, so we are at the midpoint of the project. The main motivation behind Catherine is to support CO2 MVS, which is the data simulation system used in CAMS to give estimate of CO2 fluxes. And with such kind of system, it has been identified that the main source of uncertainty come from the transport model and the transport within the transport model. And within that, there is several processes that cause uncertainties, like the advection schemes and resolution, the convective transport, the turbulent mixing, and also the numerical weather prediction analysis used as inputs. The Catherine project is structured in many work packages, which are grouped in four main topics that spans different scale of processes, from unresolved processes to resolved processes, but also different scales of models, some global model and local models. And Catherine aims to evaluate and improve the accuracy of the numerical schemes used in those models for tracer transport and primarily for CO2 MVS, but the work done in Catherine could also apply to other models used in CAMS. We want to deliver improved method to simulate resolved tracer transport in order to reduce systematic errors. with a strong emphasis on mass conservation for IFS, which is a model used in CO2 MVS. And we also want to develop test beds to assess transport errors for different processes. And we want also to provide new ways to evaluate the transport in local and global models, and propose some skill scores to evaluate the models. In the following slide, I will go through several of the work packages and present some results that has been done. So firstly, with work package 1 on the IFS advection scheme developments. So IFS uses the semi-Lagrangian advection schemes, and for which we develop case studies and diagnostic in order to understand the origin and the evolution of mass conservation errors. And we also designed and implemented new improved algorithm, and we analyzed the impact of the mass conservation error and on the transport accuracy. Here on the bottom right plot, we can see the accumulated error on mass conservation over time. The blue and red solid lines correspond to setup that were already in use before Catherine, and the other lines are over implementation that are tested within Catherine. And we can see that some of them, all of them more or less present strong improvement for mass conservation. And what is good for IFS is that enhancement in mass conservation error gave us also an enhancement when we come to the fitting to the observation. So by enhancing the errors we have on mass conservation, we also helping with fitting simulation with observations. So next on the work package 3, we did some plume simulations at very high resolution, and from emission outputs using 3 different large eddy simulation models, PALM, MicroHH, and WRF-LES, and for which we developed protocols for test cases in Rotterdam, as we can see on the top right figure, and in Paris on the bottom right figures. For the Paris simulation, here we have 3 different resolutions. From right to left, we have 1 kilometer, 300 meters, and 100 meter resolution. So we are proposing an comparison exercise for such test with such test cases. We also evaluated the sensitivity of the models to the large-scale boundary conditions. And finally, we also did some evaluation of the plume rise in the models by comparing the model to 2 commonly used plume rise parameterizations with different atmospheric condition and emission heat. So next, on the work package 5, the evaluation of the parameterized transport, we developed test beds by comparing observation data to simulation in order to quantify the uncertainties. We identified 2 regions of interest for that, the boundary layer and the upper troposphere, lower stratosphere region, which both present high vertical gradients and the largest uncertainties. For the boundary layer, we are test-based in tropical rainforest and temperature grassland forest. In the case of IFS, integrated over time, the result can be quite good, but when we look at hourly data, there is some difference with observation, especially during the afternoon. We are trying to improve that by testing different parameterizations, and also using IFS stochastic parameterization in order to assess the uncertainties we have there. And we can see that on the top plot and especially on the top left plot. For the upper troposphere and lower stratosphere region, we developed test bed by comparing model output to an ensemble of observation data using aircraft campaign and also commercial aircraft data. And here on the bottom right plot, we can see a comparison of the model output from the model IFS and ICONA to that ensemble of observation. And we identified 2 regions with largest differences, which are the high latitudes and also the upper stratosphere at mid latitudes. And we also had a look at the effect of the different parameterization on the vertical profile in the models. So for the last work package I will present, the work package 7 on global transport model intercomparison. So we developed a framework for high-resolution atmospheric model transport intercomparison. So to do an exercise using transform protocol. And we had a look at 2 traces, CO2 and SF6, as an indicator of transport uncertainties. On the top plot, we can see results for the 6 models used within Catherine for CO2. We have a zonal average on the top right, with on the y-axis the altitude, and on the x-axis the latitude from South Pole to North Pole, and on the top left the time series of CO2 for at South Pole. I'm sorry. And for SF6, we can look at the two bottom left plots, or the same zonal average plot, in which we can clearly see different interhemispheric gradients for different models. And on the most bottom left plot, this is not a time series of SF6, this is the interhemispheric gradient. And here we can see that the IFS, which has the lowest curve on the graph, presents the best interhemispheric gradient of the ensemble of model. And we also developed the diagnostics for this model in comparison, using the transfer budget equation as it illustrated on the bottom right figure. So we are looking at the delineation in total column, which is in blue here, and it is computed as a contribution of the transport in yellow and on the fluxes in purple here. And for this plot, which is for high latitudes, we can see that the total column of CO2 is mainly driven by the transport and not mainly driven by the fluxes. So I will go quick on that because I'm running out of time, but the benefit and expert of Catherine, we want to develop and test new intuitive method to improve accuracy and mass conservation in CO2 and NVS, but that can also apply to other transport model. We developed new metrics to assess the trace of transport model error and the contribution of different processes in that. We want to quantify the added value of the high resolution in models. We want to enhance the link between the NWP community and air quality community. And we also want to engage with the international community with intercomparison exercise. And finally, Catherine is related to many other projects.
Is there any question? Let me ask you one question. You're looking at the plumes and so the point sources and their impact. Now, the plumes are all over the place in the atmosphere, you know, methane emissions, NOx emissions, etc. But of course, compared to the size of the plume, the model is relatively coarse, the IFS model is relatively coarse. So how do you think we should approach the treatment of plumes in a global model like the one we're using for the air quality forecast, IFS in particular? So what should we do to better take into account the existence of plumes?
I didn't work directly on those plume simulation. I wasn't part of that work package. What thing I can think about, and maybe for after I can leave Anna or Frederic, which is the answer. We had already think, not within Catherine, with our project, using nested models. A global model with nested local models, which can help for having a high resolution look at some region, but still doing global assimilation.
Okay, good. Any other question? If not, thank you very much. And we're now going to move to the camera project, and Rose Chloe Meyer is here, and she will give us her presentation. Thank you. Take it.
Hi, hello, thank you for the introduction. So I will present the CAMERA project, which stands for CAMS Aerosol Advancement. So as it's been said before, CAMERA is a Horizon Europe project, and it is part of the project for the improvement of the CAMS product, and it focuses on aerosol modeling. So in CAMERA, we work with the different regional models and the global models, and the developers and operators of the different models are involved in the project, and in total, this represents 15 different partners. So the main goal of CAMERA are the following: the improvement of the aerosol modeling, both for the regional models and the global model, the assimilation of new sources of data, a better representation of the secondary aerosol, and also an improvement of the interfaces between the regional and the global models. So CAMERA is a 36-month-long project. It has started in January 2024, so we are now more or less midterm of the project. It is divided in 12 work packages. In fact, it's 2 groups of 6 packages which last 18 months each. In particular, there are 2 management work packages to coordinate the different parts of the project and the different partners. So the work packages are connected because some results obtained in some parts of the project are used later in the project in other work packages. I will now describe briefly the different work packages and give an overview of some of the results obtained so far in the project. So first, work packages 1 and 2 covers the data simulation and flux inversion. So concerning the flux inversion, we have worked on the dust emission flux inversion offline using an ensemble method. This is for the improvement of the dust emission scheme. And here you can see on the picture the new scaling factor for the dust emission. The second part of work packages 1 and 2 is about data assimilation. So data assimilation allows to improve greatly the simulations. However, currently in IFS, the data assimilation uses total column for the aerosol. And here the idea was to improve the data assimilation by using the vertical distribution of the aerosols in the global model. For that, data assimilation has been done with LIDAR and cyclometer. And in the following of the project, the data assimilation will also be improved, in particular for the speciation of the aerosol with the infrared data assimilation. The 2 next work packages focus on the modal approach for the global model. So the idea is to propose a different way to represent the aerosol in the global model, which is a modal scheme called M7. So this will give more information about the particle distribution size and the internal mixing ratio of the aerosol. So during the project, the M7 model scheme has been implemented into cycle 49R1 in IFS Compo. And some preliminary comparison have been made with the current scheme. This will be improved in the next months of the project. In addition to the implementation of IFS M7, nitrate and ammonium species have been added in the implementation, and this also includes a gas particle partitioning using the module EQSAM forkling. The next work packages covers online emissions and deposition. So it's quite large work packages, and I will present some of the results. So the first subject is the sea salt aerosol emissions, and in particular, the estimation of the white cap fraction. So for that, different methods have been applied. First, some machine learning techniques have been used in order to develop a neural network model to estimate the offline white cap fraction. And then this pre-trained neural network model have been integrated in IFS Compo with the help of the Info library. And this kind of work will also be done in the next months, but for dust emission. In addition, a new scheme has been developed for the estimation of the white fraction using satellite data. Another part of work package 5 and 6 is on the dust emission. So a graded version of the Northrit has been developed, including a data set of the emission that has been produced over the regional CAMS domain. And the dust emission schemes have been adapted to be used for high latitude dust, in particular for Iceland. Another part of these work packages focus on the dry deposition. So a study on the dry deposition at the level 0D has been made. So 5 models from a regional model, 5 schemes from regional model and 3 schemes from global model has been compared for different surfaces. So we have found some differences, but also some matches. And this study will continue in the next months. And also, there was a significant work during the project on the impact of the LI on the deposition. Okay. Moving on to the work packages 7 and 8 on the secondary organic aerosol representation. So for these work packages, the goal was to improve the description of the sources of biogenic volatile organic compounds. For that, we have also worked on the improvement of the representation of the SOA formation. A study has also been done for the fungal spores. So 4 different schemes have been compared and evaluated against observation. So this is nice results. However, the problem here is that we don't have access to a lot of observations, so the evaluations are limited. Okay, the last 2 work packages covers the consistency between the regional and global model. So the idea is to improve the consistency between the model. The first part of this work packages have been to compare the regional and global models. However, for this, we know that the global model uses very different emissions than the regional model, so it was necessary to merge the regional emissions into a global format. Then an intercomparison has been made with the same resolution as for regional models. And also, a study has been made to assess the impact of the emissions and the resolution in the global model. In the following, the evaluation will be completed with the analysis of PN10 and PN2.5 vertical profile, the analysis of AOD, but also a study on the matching boundary condition between the regional and global models, and this will also include a review of different approaches. Okay, so to finish, I would like to mention that Camera as a project, as a website, the address is given here, where you can find more details, information, and news on the milestone achieved during the project. Thank you.
Thanks very much. Very interesting differences sometimes between different approaches. So it's very useful to do what you're doing. Let's see if there are any questions. Yes? Okay, we start on this side and we'll go on your side.
Okay, thank you. Thank you very much for this. We've been talking about the dust a lot today and the services development, so it's good to have this service evolution part. You were talking about an inverse modeling to get the emissions of dust. And yes. Then would that be able to say something about what it is natural and what it is anthropogenic, just knowing where it is coming from?
I don't think so, no. Maybe someone's scared.
Okay, who wants to answer?
Oh, guys, maybe you can.
Okay, just maybe a response first behind you.
Yeah, he's the one who worked on this.
Yeah, yes. That's the short answer. You need, if you have the land use, we are indeed working on it in a different project at BSc using a very similar corrections. So yes, it is. It helps. Yeah.
Okay, now your question. Yeah, go ahead.
Great presentation, by the way. Earlier in the presentation, you showed a figure with AOD using the HAM7 aerosol scheme. So there was a pretty large difference, especially with the AOD in the northern hemisphere. So I'm just wondering if you've looked at, maybe photochemical impacts on species like ozone. No.
So I haven't worked on this part of the project. Maybe Vincent can answer.
Thank you for the question. And I have to emphasize it's a very preliminary result that was shown here. It really shows the difficulty of introducing a new scheme, and many things can be can explain this. So you have different emission parameterizations for the M7 compared to the air. Then the optical properties are differently treated between those, and the IFS is also complex in where processes are dealt with. So I think there was some double counting with deposition. So there's all, I don't want to show all the nitty-gritty details, but it's work in progress. So that's
okay, more work to do. Very good. Thank you. Now we're going to move on, and we're going to ask Jonathan Wilkinson to tell us about the FOSI project, which I think has to do with non-CO2 greenhouse gases, right?
That's correct, yes. Thank you ever so much, yes. So I'm a small part of this, what is quite a large project. So I'll take you through what is quite a lot of work, and quite not all of it has been done by me. So I'd really like to acknowledge the support of everybody on the FOCI project as I take you through what we've got here. Okay, so the FOCI project is a 4-year project which is due to end next year, and it's co-funded by the EU under Horizons grant and also UK Research and Innovation. It's a consortium of 17 organisations. You can see the logos of the organisations on the right, coordinated principally by Charles University here in Prague. And we're pleased to see that Thomas Halenka is in the audience. He's the project coordinator. And the aim basically is to better understanding the non-CO2 relative forces in the atmosphere and their impact on the climate system, and in filling some of the important knowledge gaps. Okay, and this is just a map of where the partners are located. You can see it's a concentration towards north and western Europe, also with Tel Aviv University in the Mediterranean, but it's principally a European and UK project, as we mentioned. Talking about the number of work packages, we have got 9 work packages, and on a variety of topics. The one that's most linked to CAMS is work package 3, that's why it's shown in blue, and verification, that's what I'm going to focus down on, the work that I'm doing in the second part of the talk. But to go through the work packages in turn, work package 1 is anthropogenic non-CO2 species. Work package 2 is more of along the natural side of the non-CO2 species, particularly around aerosols, biogenic aerosols. Within work package 3, we're looking to develop improvements in the Earth system modelling. So this is kind of like global modelling, and it's mostly kind of linked to CAMS, and this is where kind of we come in. Particularly there's EC Earth and EMAC, and particular improvements to kind of different parameterizations. Work package 4 is about regional model improvements and evaluation. So that's more kind of about coupled regional climate and air quality models, and also how those are nested within kind of global models. Work package 5 is kind of multi-scale emissions processing in scenarios. So looking at what's happened in the past, looking at the future scenarios, looking at different sectors, so waste, agriculture, human activities. And from there, work package 6 is then kind of like multi-scale projections based on kind of those scenarios and the kind of modelling. Work package 7 is then the kind of the mitigation option, so that kind of thing is climate, health, social, economic. And then there's a work package 8, which is led by the WMO and the World Health Organization. That's kind of in the global dissemination and the communication. That's an interesting side of things. And then overall, work package 9 is kind of like overarching kind of project management. This is kind of a nice kind of chart we've had from FOCI, which basically kind of shows how the process understanding on the left passes through kind of over to the right, so it feeds into the modelling, which then feeds into projections, and then feeds into kind of the mitigation, along with a number of cross-cutting activities. We have regular project meetings, so we have an annual in-person meeting, so we had one in Hamburg last year in June, and again in June we went to Milan this year. So there's photographs of the participants, there were people online as well, so that's not everybody who was there. In between there's quite a number of monthly meetings for the individual work packages, and there's kind of like an annual online meeting kind of 6 months after kind of the main project meetings. We had one around kind of January. One of the key things that I found quite interesting on this is you learn an awful lot about the other areas. My background is in kind of the modelling side of things, so learning about things like stakeholder engagement, learning about how these climate science results are passed down to other people, non-specialists, to politicians, that was a big kind of eye-opener for me. And also kind of some of the details between some of these emission scenarios. I've often, as a modeler, I've seen the kind of the output of these scenarios, the final end product, if you like. But what I haven't seen is kind of all the thought process that goes behind it, the things that feed into these, you know, how will agriculture change in the future? How will waste management change in the future? How will humans develop in the future? And so it was really a big eye-opener and really interesting to listen about how those sort of thought processes behind them. And it's quite nice to present, you know, your own work with the other scientists who are obviously non-experts. Okay, so moving on, this slide has been provided by the people working on Work Package 3, so I'd like to sort of thank them for this. This is kind of what they're doing. There's 2 models particularly involved, which is EC Earth 4, which obviously has its roots in the IFS, in Open IFS, and there's the EMAC model, which is Max Planck in particular. And this work's all basically being done in improving atmospheric chemistry and kind of aerosol routines in these 2 models. And the kind of key take-home from this is that there isn't really anything that ECMWF has done, so maybe you're thinking, well, what is our particular part in the project? What can we do? And then that leads me on to kind of, well, how does this kind of like fit in with the kind of the CAMS development? So what we've been trying to do under this task 3.4, and this moves more into my work now, is to kind of aim to develop some tools which in the short term are going to be suitable for FOCI, really support our FOCI project, but in the long term can also kind of benefit CAMS verification, because there's a lot of verification that we're doing internally at ECMWF to try and improve CAMS. We're trying to say, is my model better than the previous version? Is the new developments we're putting into CAMS better? So the first one of these, I'm just going to go through these fairly quickly. We've been working on a LiDAR evaluation tool. We don't use LiDAR evaluation in CAMS internally at the minute, so we've been working with the EarlyNet data sources. We're obtaining their data. We've been downloading EarlyNet data, so we're grateful to them for it. There's a number of stations, as I say, on the map clustered over Europe, but it's obviously not as simple as it sounds. And part of the reason why that is because the LiDAR signal has contributions from lots of other things. So if you look on the plot on the left there, that's the LiDAR backscatter, and you can see there's a number of different things there. There's molecular scattering in there, there's aerosols, and there's not in clouds in this particular not particularly many clouds, but if there are a lot of clouds, they also interfere with the beam, ice clouds, liquid clouds, fog. And what we want to do is we really want the aerosol signal alone, but so we have to kind of extract that. So what the LiDAR kind of measures is attenuated backscatter, and what we're measuring also kind of attenuates or reduces kind of the signal kind of from the LiDAR. What we're really interested in is kind of like in the aerosol backscatter, and it's also been extinct. And the model has one variable, which is mass mixing ratio, and the observation variable is a completely different thing. What we've done is we don't want to go from the observe variable to model variable because that was too tricky. We did try looking at doing that. But what we've done is we're trying to simulate the kind of take the aerosol and kind of simulate what the LiDAR is seeing. IFS is able to output basically aerosol backscatter and both attenuated and unattenuated. But operationally, we only really kind of output the unattenuated backscatter. Whereas EarlyNet have gone the other way. They sort of said, would like to give you the unattenuated aerosol backscatter. We think that's what would be most useful to you. So currently on cycle 49R1, which is the operational one, we don't have complete aerosol backscatter, but we're hoping to add that in the future and use that as part of our evaluation. So I'd like to thank Sam Remy, who has provided me with some data that has got aerosol backscatter in it. And this is kind of an idea of what the sort of thing we can do with our sort of LiDAR evaluation tool. This is just a single time profile, but we can extend this to a kind of more and produce statistics over it. And what we see here is CAMS in the red, and then the observations from EarlyNet are in the black, both on the left and on the right. So we've got the aerosol, so the backscatter and the extinction. The profiles, this is a vertical profile over Portugal, the Evora LiDAR, and kind of say that we're getting the kind of right sort of idea, but it kind of gives you an idea of whether we're overestimating, underestimating how long it is. Finally, moving on just to complete, the other thing that we're trying to do, or working at the minute, is looking at some IARGOS verification internally. Currently, there's some external verification done on the CAMS 282 contract, and we must stress here that we really want that arrangement to continue. However, what we don't have at the minute at ECMW, if there's any support for somebody making a model change and saying, does my change to CAMS kind of actually improve things? We can't just use their code due to IPR issues, so we've written some, or trying to write some in-house software which we can then use on the FOCI experiments to kind of evaluate how they're performing compared to IARGOS as well. So with that, I'm going to kind of wrap up. I'm happy to take questions. It could be that if you've got a question about one of the other work packages that somebody else in the room might know more about it than I do, but I'm definitely happy to take questions on my own work as well. Thank you.
Questions? Please.
Tomáš Halenka, Charles University, Department of Atmospheric Physics. And actually, as was mentioned, so I'm coordinating the FOCI project. There's not, no, well, thanks for a nice presentation. It's definitely fine to hear at least once some other person presenting that overview of the project. Well, one comment that is something which you mentioned on one slide, but not discussed so much, but it's, I would say, quite critical in connection to regional modeling, and that's inconsistency between global data which are used in CMIPS experiment, which is SETS, and they are not containing the PM data which are commonly used for regional simulations. And that's something which probably would be really relevant for this platform to discuss, that we spend quite a lot of time and make some delay within the project when preparing some relations to get PMs based on that sets data. Even that we found some differences even in, because we tested with respect to, say, a few data sets, so to CAMS as well as EDGAR and EMAP, and we found that these databases actually as well are not exactly consistent or having different classification of sectors, and moreover even overall values actually not exactly the same. But, well, fortunately, the differences in simulations were rather still in the limits of overall bias of the models, so that was fine. And I would like to use this occasion as well for some kind of inquiry, because it's again connected to that regional simulations, because nowadays there are actually not only in FOCAI project, but even in other platforms, that's effort to make climate change or chemistry climate interactions for the future. And unfortunately, there is not so much available driving data for the regional simulation. So, because I suppose there are many people here from individual global air system chemistry climate modeling groups, maybe it would be nice if there would be some, say, effort to get store that data which could be used for driving regional simulations. I mean, driving data even for chemistry, because within Cordex MIP actually there are climate data or methodology data, but chemistry data actually are not so much available for the driving regional simulations. Thank you.
You have the reanalysis.
So long.
You have the reanalysis, for example.
Oh yeah, but you need something as well for future simulations.
Okay, Richard.
Yes, maybe just as a response. So thank you, Thomas, for these comments, and we discussed part of that earlier. So I think this indeed interesting feedback from the FOCAI project coming about the emission data that we also use in CAMS, and we generate our own European and global data sets. So any feedback coming out of the project could be really useful to see if we need to adjust things or not. In terms of the support for regional climate simulations for the chemistry part, this is also good feedback to have, especially thinking about the next phase of Copernicus, where we might want to think also on how do we support this part and do longer climate supporting runs if we can. It's not something we can currently easily do, but it's certainly something we can keep in mind for the coming years.
Good. So interesting point made. Point well taken. This is good. Let's see if there are other questions. Not yet. Thank you very much.
Thank you very much.
Okay, so we heard about 5 projects, which, by the way, were extremely interesting to further develop CAMS. But there are other projects also, and Richard Engelen will talk about other Horizon Europe or also ESA project that could add it to what we already heard. Please.
Yes, thank you, Guy. So I'll go fairly quickly through a few extra additional projects that we are interacting with and that are relevant for CAMS, that are not part of these CAMS development support calls, but still very relevant. But before I do that, I want to elaborate a little bit on what Natasha already introduced to some extent, and that's why these projects are so critically important for CAMS as a service. There's quite a bit of text here, but I think it's important because in the contribution agreement we have with the European Commission, there's sort of a definition of what it means to run operational services. And this was a point of discussion before Copernicus even started. How do we define an operational service and what does it include? And in the end, everyone agreed that, yes, you can run services, but you need to keep improving them. You need development in order to stay state-of-the-art and make sure you're still relevant 10 years from now. But then how do you implement this, and who's paying for this? So what we agreed on, so quite a few years ago already, is to define 3 tiers of development, tier 1, 2, and 3. Tier 1 and 2 are part of Copernicus as an operational framework. Tier 3 is not, and that's exactly where Horizon Europe comes in to support that. So Tier 1 focuses on very short timescale developments. I mean, you
well, they are sort of developments, but they might also be corrections. It's also dealing with changing and observing systems, taking out a satellite that doesn't perform well for a period, things like that. So it's very focused on keeping the operational service running as best as it can. Tier 2 is basically prepare new developments that are candidate for operational implementation. And this is exactly where the CAMS contracts we have, for instance, for the IFS development come in. So yesterday there was this meeting of CAMS 235 that I partly attended, and those discussions are exactly focused on this. How can we improve the operational service within 1 to 2 years from now? So we have a target of implementation, and we prepare that. This is for the global system, but it is relevant for all the services we run within CAMS. Then tier 3 is how do we make sure we are still relevant, that we still have good products 5 years from now. And that's where Horizon Europe is critical. So it's riskier and longer undertakings, but those are essential for the medium to long-term upgrade of operational systems, or even develop new services like we see with the CO2 MVS. So it's really important to have that support through Horizon, so we can really make sure that we stay relevant as a service. However, this is not this is not straightforward as it might look like, because how do you make sure that these project results end up in your operational systems? So there's basically 3 different ways. One, the top one here, is that you work on developments within these projects and you work directly on the CAMS systems during the project. So this needs the relevant service providers to be part of these projects. And this is happening to some extent. ECMF is part of it, but also some of the regional modeling teams are part of some of the projects, solar radiation, etc. So we can do this. So this is the easiest way, the most direct way. We directly work on the operational systems. Then the second way is already slightly less direct. We basically develop things within the projects, but they might need a little bit more work after the end of the project before they're fully mature. But these can be picked up in the development contracts or part of some of the service contracts actually we have in place by the relevant CAMS contractors. So this also needs some overlap between the project partners and the actual contractors we have for CAMS. Then the third way of doing this is basically develop within the project, publish this in the peer-reviewed literature, share this with the wider community, share it with CAMS as a service, so we can pick this up and write it into our ITTs that based on such projects, these are new developments, and we would like to bring this into the service. So this opens the floor to basically the whole community in Europe to benefit from these developments projects, and then bring them into further CAMS developments. So this is even more indirect, but still quite relevant. And that's why it's so key as part of these projects to make sure we not only develop, but we also document and we publish in the literature as part of these projects. So that's where I stop. Now I'll use my remaining time to mention a few other projects that we collaborate with. The first set are actually 3 projects that also work closely together as such, because they're all part of the same goal, but in the end 3 different projects were funded. Paris, iClima, and Avengers. You can find more information on the websites that are listed here. They all look one way or another at the estimation of greenhouse gas emissions. They might differ a little bit in what species they exactly look at or the methodologies they use, but it's really tried to develop further the methodologies to estimate emissions and fluxes of the most important greenhouse gases. So there has been a really nice collaboration, and actually we also collaborate with them to some extent, and the most prominent part of that is that we generate a newsletter about once or twice a year, presenting new results from the projects. This newsletter is actually mostly aimed at national inventory agencies, so national agencies that are potentially interested in observation-based emission estimates. So we decided to just work together and publish this newsletter with the projects and CAMS involved as well, mostly to be more focused when we talk to these national inventory agencies, that they don't hear this from that project, that from that project, this from CAMS. We really want to have consistent messaging. Then a couple of other projects I just want to mention, and I can't be fully comprehensive here, so I'll probably have left one or two projects out, but I just tried to have the most relevant projects that we work together with in terms of also with an eye on developing CAMS better. So IMCA is a fairly recent project, also coming out of Horizon, and really looking in very much detail at methane. Specific field campaigns are part of this, really doing detailed measurements of wetlands, for instance, across the world. So gathering a lot of observations, but then there's also a modeling component and try to see how we can further improve models that can model methane fluxes. ECMRF is actually involved there as well, because we really want to try to see how we can benefit from all these very nice observations that will be made, and also some of the modeling activities that will happen, and how can we improve the IFS in terms of our methane modeling. Another project to mention is AD4GD, and that project is focused on looking at basically low-cost IoT sensors to see how we can make better use of low-cost sensors that could be distributed in just communities, just citizens making measurements, and how can we benefit from that. So we have been part of that project, trying to see what was developed there and what would be relevant for CAMS as a service. And then my last slide already, I'll keep it brief, just to mention that ESA also funds quite a few projects. I'm highlighting here World Emission, which is also very focused on looking at emission estimates for greenhouse gases and some of the pollutants. So we really follow this project and see where these developments can potentially benefit CAMS services, and building up knowledge in the project that we can use in our future ICTs. And then also within the CCI program, and I'm not going to go into the details because Michael already talked about this, there's a lot of things happening there as well that can also support our further service development. So really trying to benefit as an operational service from the research that's happening elsewhere, funded by the Commission and by ESA, and in some cases actually also national funding agencies. And with that, I'm finished, and I thank you for your attention.
So, thanks very much. If I had to summarize by one word what you said, is it true to say increasing emphasis on greenhouse gases and climate relevant as opposed to air quality? Is that a trend that is coming up slowly, or maybe even quickly?
Well, yes and no. Of course, for air quality, this is as relevant as it ever was. So we need to make sure we keep improving and keep coming with policy relevant data. The greenhouse gases is just something that was started new as part of this current phase of Copernicus. So we have been allocated by budgets to implement the C2 MVS. ESA and EUMETSAT are working on CO2 emissions. So yes, there is a large focus on this, and Horizon has been used to really prepare the groundwork for these services. So we really benefit there from Horizon Europe. That funding is slowly tapering off, and the CAMS funding is ramping up as things become mature and we can implement the operation.
Okay, so maybe we have 10 minutes for kind of final discussion, so you stay here, but maybe the other speakers could come back. I don't know if Natcha's still online and if she would appear or not, but
yes, I'm
where
still
are the
online.
earlier speakers? Please come here for a few minutes. Okay, we we have time for the question the burning question that you didn't ask up to now. Let me start with one just to start the discussion. If I look at the evolution of air quality in the last 10 years or so, with some exception, we see a reduction in the anthropogenic emission of many reactive species, which means that the air quality or the composition of the atmosphere will be again increasingly controlled by biospheric processes, including the cities where we put trees and we have isoprene emissions, we have a lot of probably NOx emission due to agriculture in a way which is not completely natural, but the biogenic component will play a more and more important part. So this is maybe a trend for the future. So how would you think about that? How would you consider it? And that's also true for methane, that's also true probably for CO2 in a certain way. So how would you better investigate the difficult problem of the biosphere-atmosphere interaction in terms of probably some greenhouse gases, but also air quality? Does anybody want to say something about that? Near the microphone, maybe.
Currently, yes, I think this is definitely true. We see that in every city that there are increasing efforts to increase vegetation, and this leads to interactions with local high ozone levels and so on. So yes, I think this will become increasingly important. From my point of view, where I would start is that I would definitely increase the scientific knowledge of these biogenic processes in their source regions globally. We always see that we have sort of a knowledge and observational gap when it comes to the tropics and the southern hemisphere compared to the northern hemisphere. So if we say that biogenic processes will become more important, then we should also look at them more in terms of observations and research. Yes.
Good. In the meantime, I see that Nasha is back, so good that you could reconnect. Okay, anybody wants to say something more about this? So otherwise, we can go to another question. And if there is no question, I'm going to try to create one. High resolution. High resolution. The models now go to, even the climate models are thinking about 1 kilometer resolution in the future. So I think the resolution of IFS is about 40 kilometer, but you want to go to higher resolution also. So what is the plan about achieving that? And as you deal with regions that are really very populated, urban areas and so on, is there a way you could refine information in those areas that are high resolution areas? Maybe that's for you.
Okay, I'll try. Yes, resolution. So currently IFS Compo is 40 kilometers. The regional CAMS models are 10 kilometers. And the greenhouse gas forecasts from the IFS are 10 kilometers as well. So yeah, there's certainly scope to improve. With the IFS, we do see though that it's not necessarily straightforward. If we increase resolution, we don't necessarily see improved forecast scores. So that's something we need to watch. So yes, resolution is nice, but you also want to make sure that the forecast is actually correct. So there are a few things that are trying to push things further. One is using machine learning to go to downscaling, which is one option. So there's quite a bit of activity going on there. The other thing is just to just push things and try to see what happens. And that's, for instance, to some extent happening in Destination Earth, where we run at really high resolution some of the global models. So there's different ways to explore this. But yeah, we have to be a little bit careful. It's not just you change the resolution, everything will be better. We've seen that it's not necessarily so.
So my next question, provocative question, you mentioned yourself artificial intelligence or deep learning, or you see now in the private sector some companies like Google or others who claim that they can provide a global air quality forecast much, much faster than you can do it at ECMWF by using artificial intelligence. So, provocative question, are you not afraid to be behind soon because of those companies who are, offering fast, they claim reliable prediction like this? So what is your view on that? Provocative question.
At the moment, I'm not afraid. We have someone really clever sitting there, making sure we stay ahead. No, it's something, we've gone through this, well, still going through this for NWP forecasts at ECMWF. So we know the challenge, and we're trying to deal with it, because, of course, it's important for our own existence. We need to make sure we are relevant and provide the best forecasts that can be made. And within CAMS, we are now following in that same framework and try to see how we can push this. The atmospheric composition problem is not the same as the NWP problem, so there's a few other things to take into account. So we can't really predict how far we can go with this, but first results look actually quite promising already. And I know there's also thinking on the regional scale how we can make use of this. We already have the observation-based machine learning forecasts as part of the regional service provision. So these are for observation locations only. Bringing that to gridded forecasts is another step. So yes, it's something we are looking at, we need to look at. But yeah, I'm fairly confident we can make good progress.
And so my last question is, okay, go ahead,
A more general question. It's about sort of how to prepare for the future, and we have these horizon goals.
But that's what we're discussing here.
And my question is about what is the best process for this, because of course we may not know what is necessary in 10 years' time. So it's basically a question for the people writing the invitation for the proposals. They are relatively prescriptive for the Horizon Europe projects. What can we do to make sure that we really don't forget something? What is the process for scoping these projects?
Natasha, do you
Good
want
question. Let's go to Brussels.
To Brussels, but I think you have Hugo there, who is the right person to reply to this question, because he's from DigiDefis. Because as I said, we execute what the Public DG is doing. So maybe Hugo wants to elaborate on that, because I see him sitting there at the front line.
Thank you, guys. You pay a beer next time, yeah? Yes, well, obviously that's a quite complex question. Predictions are difficult, in particular if they concern the future. So this means that before we are really trying to elaborate or going to elaborate work programs and so on, we have a process which makes reference to the strategic research agenda process which we have. We elaborate this together with stakeholders, with experts, so part of you have been part of this process as well. In order to arrive at something which is indeed relevant, considering as well the nature of research projects, so it's a grant, etc., etc. So, and secondly, as well the time frame. So I need to think today about a result I might want to have in 7 years, because it takes time to make the call, it takes time to make the grant, and so on. And this strategic research agenda is updated, I would say, each couple of years together with the community. And that's basically how we try to make sure, at least, that we don't miss anything which is maybe completely obvious, but not for ourselves. So basically, this is a process. And then, concretely, work programs are elaborated on the basis of this. And then the concrete calls are indeed then done by Hadea, prepared with all the documentation that is necessary. What you see then every year on the website.
Okay, let me finish by a question that I'm not supposed to ask, but that everybody would like to ask. The future is not predictable, really. But when I read in the press what happens in Europe, in particular with the future of the budgets, the future of the Green Deal, the support for environmental questions, I'm a little bit nervous and a little bit perhaps pessimistic, or at least I'm asking myself question. How are the budget for environmental issues going to increase or decrease or change in the future? So it's difficult to predict because it depends on the Commission, it depends on the Council, it depends on the European Parliament. But what, at the management level, you're closer to those discussions than we scientists. How do you see the evolution of environmental activities, projects, in the framework of the European Union? Can anybody say something about that? Maybe it's not the appropriate question to ask, but I'm sure that you all would like to know the answer. I don't know.
It's probably more a question for tomorrow's closing session. I mean, I can say that Hugo would fully agree that the budget only goes up, but that's not the truth. I don't know. I don't think we can say much about this.
Probably nobody knows, but still, it's a concern.
Yes, I mean, yeah, it's too early really to say something concrete about that. Some of you may be aware that on 16th of July, the Commission has made a proposal for the next 7 years' budget, accompanied by the draft regulations for the spending programs, such as the Competitiveness Fund, and the space topic is part of that. Earth observation is part of the space topic. Then Copernicus is as well inside there. So, and this is a process where the budget lines are defined at the moment at a pretty high level, so aggregated level. So I don't think anyone in my house or in my DG has any concrete idea how this will be broken down according to the budgets. Now, having said that, I think in general the environmental topics, climate change remains high on the agenda. I think we can see that. But clearly there are as well other policy priorities in Europe in parallel. So how all this is going to play out is indeed at the moment, at least for me, not predictable, right?
Right. Thank you very much. From Brussels, still a comment before we close?
No, Hugo covered very well. We don't have any information now on the upcoming framework program. And what I always want to say that it's not only Commission in charge, it's always the member states. So, you have to talk to the member states to better understand what their priorities, because they will be discussing together with the Commission, and then there will be the next framework program. So it's not only European Commission, it's really the member states and what are their priorities.
Okay, well, thank you very much. I think we should be positive and just carry the message that what we're doing is of high quality, is very important for society, and we need to convince everybody that it should go ahead. Thank you very much.
Is it on now? Yes. Sorry, very quickly. very quickly. So yes, this session is closed. The day is closed. Thanks to everyone for presenting the really good presentations and staying on time. So the next part of today is our evening event starting at 7. How to get there is in your program. You click on the link and you get a nice Google, or even there. So see you all this evening.